You have a 1,000
Five,
grams.
4, 3, 2, 1. Are we doing it now? Is it going through?
Scales are. I'm looking at them, but do we have a 1,000 gram scale? Yes, there is.
It was. All right, I think it's going live now, finally. All right, we are live now from the lab, and we wanted to do an update. We have Jeremiah here in the live chat with Chris Lumen and Pablo. We have some others be joining us shortly, and pretty soon we'll open this up to live audiences too, for anyone in our stream that wants to participate and join us with this. All right, I had to figure this out because for some reason it wasn't working, but now it is. The output stream and everything. So I got all these. I don't know if it was too many cameras running at once, but it didn't do the output stream quite. All right, can we hear you guys? I just want to check your audio and make sure that you guys are coming through 100%
Well, there's a heat gun
clear.
in the background, but can you guys hear us? Can you guys hear us at the Falcon Space Lab out here in New Jersey?
I can hear you loud and clear. Yeah, let me put them through my headphones so that way.
Oh man, this is nice. But we do need 2 AAA batteries.
Only if you have money.
Where might we find?
It's not a big deal.
We just got some right there. Right next to it, to the left, under my.
Ah,
A 6-pack of Modelo, I'd be cool with that.
man,
Probably not that much.
I do appreciate you. So
$3 cash, but
I say it so you know.
wait for some people to show up, guys. Why don't we let everyone know what the heck is going on here, man?
Yeah, well, right now, quite a lot. In fact, I think it'll make more sense 5 minutes from now than it does at this moment. Right now, I am just now setting up a digital scale that we've never used before with a 2,000 gram limit, 0.01 gram, 0.1 gram resolution. I highly doubt it's as accurate as its resolution. Either way, so we're setting this up so I can weigh exactly how much mass we stuck in the last electret. And this time I'm going to try a formula so I can start to write these things down, because we have a formula that cracks under electric fields but does not crack under natural cooling in a Pyrex dish. So that's
explain to them what a
yeah. Let me go ahead and we'll start by showing some of this stuff. I can bring this over.
Yeah, nice. I already posted some pictures of that.
Yeah.
The million volt Marx generator that you guys were building.
Yeah, well, it's only half built yet. I mean, okay, I'll
we want to show that
I'll hold
off.
that thing up for cam when we have more viewers. Anyways, yeah, just for now, this is the piece you can see is glossy.
Looks like a giant capacitor or something.
Yeah, it is basically that's what it is. It's saturated with a calcium copper titanate, which is one of the most phenomenal dielectric materials we've ever heard of. It's amazing that you can just order the stuff online. It's a bit of a long shipping time. Let me go ahead and show you guys what that stuff is. So don't breathe it, which luckily on the internet you don't have to worry about. So here it is, calcium copper titanate. It has a dielectric constant of 200,000, which if you've ever looked at dielectric materials, that is a ridiculously huge number.
I'm not sure if I believe it.
I'm not sure if I believe it either. Now the manufacturer, I did go ahead and read some of their data sheets and how they talk about using this stuff. And in order to get that kind of dielectric constant, there's very specific requirements on the binding agents used, the pressures used, the thermal heat up, cool down, cycle time, dielectric polarization, and a whole bunch of other stuff in order to get that kind of crazy K factor out of it. But the fact that it's even capable of doing something like that under certain test conditions, I think it was at 1 kilohertz they tested, which is pretty standard for testing dielectric materials. There was a variety of different frequency tests, including lower frequency ones. Either way, it's a crazy good material. It's drastically better than titanium dioxide, which is a common and very cheap material that a lot of home experimenters use, such as Wayne, our Canada researcher, who has produced a video a long time ago, which I actually saved on my Gravity Engine Required Knowledge playlist because it was so good, where he builds a wax and titanium dioxide brown gravitator and shows that in one polarity it loses mass and in the other polarity it gains mass. It's a very interesting setup and particularly good. He powers it with a Van de Graaff generator, which is an isolated system with no ground connection. Very important if you study Banduric. Go ahead, Jeremy.
Sweet. So, yeah. Did you guys get PPE from, safety goggles for working with the liquid nitrogen? Now we really should encourage our audience to have proper safety guidelines when we're doing videos.
I would recommend don't do what we do.
Yeah,
because
don't.
we're probably doing it wrong, and feel free to correct us.
It was funny. Like people were making fun of my Ali G goggles and my hat in the last thing because I
thought that stuff was cool, man.
I thought it was funny. I'm glad a couple people got the reference and the joke a little bit, but at least I was the only one wearing PPE in the whole video. For real though. Technology. In any case, we got to get if we can get some people down to this lab. Basically, I want to encourage with the lab. I want to basically is a safe haven for people to come forward with information and technology to share it with the world and share it with us. It's a learning experience for us and a learning experience for also much of the internet as we're introducing 70 years of anti-gravity research and technology and a lot of research that people have done that is just not widely known about. It's just not well known about. It's not well documented, and we're talking to a lot of the people who are there for a lot of the history of that, and bringing through the history of it as well as where we think it's at today, and also merging it with what we're learning and understanding about some other things like just metals and stuff. I've been trying to connect the dots on a lot of different issues, but I'm not quite sure if we're ready to go fully there yet. But basically with this channel, with what we're doing with APEC is it's got two sides of it. The conference side is to kind of accelerate what was being done at Estes Park and STAFE and a lot of these other conferences that were they kind of fallen apart with COVID and the way the restrictions are run. And also we thought that running an annual conference was just too slow for the pace of progress nowadays. Is that so much is happening so quickly that we almost need to host a weekly conference to discuss these things and hash out these ideas. And in conjunction with that is the Gravitics lab and setting up a lab where we can actually do all these experiments and that where we can encourage people who have devices to come and bring them in for testing and verification if something works. There's a lot of other groups that have worked on this kind of stuff throughout the years. There's a lot of claims about it on the internet you'll find. And, we just want the truth and we want to bring information out to the public. And also, in addition to, while we're running these experiments, we just want to educate people on, the science of it and kind of engage them and encourage them to get involved personally as well. I think in order to fund this, we're going to need to set up a website with some marketing tactics. We're going to have to talk about that at some point on this broadcast. I want to talk about T-shirts, things that we can sell on the website. We also have a couple different ideas and inventions and things and products that we can also sell. As well as do-it-yourself kits where people can assemble things and put them together, where we basically sell the kits for different things.
Yeah, I got you guys covered on that. That's coming soon.
Yeah, so we're going to get working on some of that kind of stuff so that we can have some cool things for you guys to buy, and also that you can help fund and support the lab in addition to the donations that we've received and stuff. So I'm hoping to put that together. We're going to have some discussion on what kind of things we want to sell, and then also we got to get some designers and some graphic artists in to come up with some cool T-shirt designs for researching anti-gravity and kind of different theories, and bringing some of the intrigue and interest in this out to the public so people can stickers and stuff to post around universities and physics departments and flyers and stuff like that. I also want to work on so that we can kind of spread awareness around, get more young people interested in the science and get more of the young scientists who are interested in, who like the physics and like the math and like the science and stuff and aren't quite sure what they want to do with it quite yet, and show them that this is sort of the future, and we want to focus on energy independence, things that will break, anything that's energy, super efficient energy, free energy would be great. I think it's kind of a dream, and I don't really want to waste a lot of time entertaining that at this point. But we're certainly welcome to that at the lab as well as people, because one thing people mentioned out in the last conference is, why are you guys talking about anti-gravity and propulsion? You should be talking about energy. How do you going to power this thing? So even if you do create anti-gravity, how are you going to get the power to do it? That should be your first priority, is looking at power supplies and power. Once you have power, you can do as much as you want with power, and I don't know if that's really the answer to all of this.
Not right now, it's not.
The Earth doesn't use a lot of power, and it does kind of use a lot of power with electrical lightning bolts and stuff, but the way it does that is super efficiently, and it does it naturally in ways that might be more, I think it's more close to the way that we all agree that there is a little bit of reverse engineering goes on in this group, and I think we've all kind of like looked at UFOs and that kind of aspect of it as a sort of a cheat sheet, as a possible cheat sheet, as is there any answers here? And I've certainly delved into the conspiracy theories and all the conspiracy stuff myself, so I can speak for that. The Roswell is something that's always intrigued me, with the metals that they found and the reports that there were no visible means of propulsion system. There was no propulsion system that they could come up with, and then they eventually were learning that the metals themselves were the skin of the craft was the propulsion system itself, and that sort of things always kind of led my what we need to be eventually working towards. It's nice to do a lot of these experiments and get through all the history of this stuff as we're doing with all the get all these old timers on. This is great. Talk to all these guys. They have so much knowledge to share. It's almost like trying to take a drink from a fire hose with the amount of knowledge that and information that these guys have shared already, and then trying to piece this all together. We got Gary Stevenson talking about how to calculate gravitomagnetic high-frequency gravitational waves, and then how to detect those. So there's obviously some type of coupling. If you can detect stuff and see stuff, then you're doing some type of coupling with electromagnetic waves and gravity. And if there's, we were just having this discussion before, right, guys, about if it can go one way, why can't it go the other? If you can detect stuff, why can't you if you can receive, why can't you transmit?
Yeah, exactly. Is it a reversible system? I mean, I don't think that Gary would have bothered wasting time talking about the Tic Tac if he didn't consider the idea that maybe it is a reversible system. I mean, basically what we're talking about here is a gravitational wave detector, a very clever design, which uses a very powerful magnet to set up a field in which a electron beam is sent through that powerful magnetic field. Now, if a gravity wave is effectively space-time compression, when that wave goes through, it's going to create a small time delay in that beam of electrons. And as they compress as a result of this time delay from an external frame of reference that's fixed, they produce what we see as an observable photon. I could have gotten some detail wrong on that, and I'd love for Gary to correct me on that. But from what I understand, that's basically how it works, is a gravity wave travels through this thing along a certain axis, and it compresses space and time itself, which causes this electron beam in this extremely strong magnetic field to produce a photon, which then can be detected with external detectors. So it's a rather sensitive system, and the key here is to remove the noise floor with a very, very powerful magnetic field, which is achieved through superconducting magnets. But yeah, the question is if space-time distortion can fluctuate the system and produce photons if we input photons or fluctuate some other parameter in the system, like say the electric field or the magnetic field very, very quickly, could we potentially produce a gravity wave? And I know earlier there were being links made. I think Pablo had several comments on it, who's in the chat but temporarily out, about doing specifically that. It looks like Mark's getting set up here for a external, so I'm going to head off now and let you guys chat for a bit while we get camera set, and then we'll go over some of the stuff that we're working on here in the lab, and we'll talk about some of the electrodes that we briefly tried, and go over the new multiplier stuff and a mold that we're working on for a Thomas Townsend Brown replication. So
yeah, man. So we're trying to we got a lot of cool stuff going on at the lab right now. I hope to be back down there shortly to help build some of this stuff and get my hands dirty with some of this too. Of course, as Christmas is right around the corner, man. I can't believe this is like we're wrapping up 2020, and this is how we're doing it, by setting up like the a mission which very well could lead to, you know, the first discovery of gravitational electromagnetic coupling or way to control gravity. That's basically what we're after. We're digging into the past of as much research as we can find, and talking to anyone and everyone that can come forward with any information. And of course, we have a round table of skeptics and scientists to kind of cross-analyze and pick through that information and try to find, you know, what's the best and what is not, what is useless information and what's real, what's useful, actionable intelligence, like what's actually going to get us there.
Okay. Let's talk about what we're doing over here. We're making an electret, and we're trying to shape it at this angle, trying to make a asymmetric dielectric. And in order to do that, we are going to pour this plaster of Paris around this and use that as a mold. I had to put a piece of aluminum foil at the bottom because that is going to be one of the electrodes. And we're going to mix up the plaster of Paris right now, and hopefully we'll make a useful mold for our electret system now. Jeremiah, you can explain what an electrode is while I start mixing up.
yeah, so let me go over this. I have this fantastic gimbal camera device that I'm still figuring out how to use. This thing is super, super cool, but I'm just getting used to the controls. I mean, check this out. I got this little joystick on this thing. I've never used one of these, so don't mind me if I'm absolutely enamored like a kid in a candy store with the fact that I have this joystick that I can move this thing around and it's like dead stable. Okay, getting on to the important points.
Electrets.
I'll go ahead and show you. I'll show you one of the failures that we went through earlier.
What is an electret?
So the idea with an electret is this. If you take a look at a normal capacitor, which is composed of two plates, I'm going to set this cam down for a minute, Mark.
Okay.
So here you go, boring counter view. An capacitor is made of two plates property leakage, which means that if you place a charge that's different between the two plates. What's up, Jeremy? What's up?
Hey, you guys are
Hello?
not coming through. I don't know, for some reason you're stalling out and your feed's not coming through. I don't know why you're not. It says my connection's excellent. I don't know if it's your connection. Might be.
It is.
Might
Try
be
me now.
Why don't you turn the gimbal camera off temporarily while you're not using it, so it's not taking up so much bandwidth, and then try it again. Yeah, there was some big packet loss. Try that again. Start from the top, man, on that explanation. What is an electret?
The camera is off. Yeah. Okay. Okay. So, in order to understand an electret, you have to kind of have an idea about a normal capacitor. A normal capacitor has two plates with a dielectric sandwiched between them. So you have one plate, another plate, and between these two plates, you have some kind of dielectric material that can store electric charge by having dipoles that can orient between those two plates. Now, capacitors have the unfortunate property of leakage, which means that if you place a bunch of electrons and take them off one plate and you stick them on the other plate, so now this plate has a lack of electrons and this one has an excess of them, those electrons, a few of them, will make their way and wiggle their way through the dielectric in order to finally make their way over to the positively charged plate to neutralize some of those unbalanced charges out. And so normal capacitors will lose charge over time. So you charge up a cap, you leave it sit over a very long period of time, and you measure it, and it will have lost some of its voltage. Electrodes are a bit different because unlike a normal capacitor, they're just simply made with materials that are polarizable. An electrode is made with a polarizable material that's locked in its position under an extremely strong external electric field, which means that all the dipoles that would normally be responsible for allowing a capacitor to charge or store charge, all those dipoles are already stretched as far as they can possibly stretch, and they're all oriented with the positives towards one side and the negatives towards the other. The term electret was actually coined by Heaviside long time ago when he was talking about what would be the electric equivalent of a permanent magnet. So instead of a magnet, he called them electrets. And he had never actually built one, but he theorized how they might be made. And since then, we have several papers written about the study of electrets and the successful replication thereof. And right now, we're just sort of dabbling with what is a 1951 set of papers that talks about the study and properties of these strange electrets, which holds their electric fields. Now, here's the strange thing. If you discharge a normal capacitor, that's it. It has no more charge. If you discharge an electret, it's unstable. It actually wants to recharge itself because only when there is charge across its plates is it in a stable position, because all those dipoles are aligned. So in order for all the positive dipoles on the positive side of those atomic spins to be neutralized, it has to suck in electrons from the outside atmosphere and stick them to the surface. And for the negative side, in order for it to be neutralized, it has to suck in positive ions from the atmosphere and for them to stick there. These positive ions and electrons tend to get stuck on the surface of an electret that's properly made, causing them to reverse polarity over a period of time. But you can remove that charge by simply recharging the electret even once it's made and sucking those ions and electrons back out of the surface. We're just trying to replicate basically what's been done since the 1950s, and it's incredibly hard to do.
I'm going to be turning on the vacuum chamber if you want to see something cool.
Yeah, we definitely are going to need that for the CCTO.
Oh, you guys got a vacuum chamber?
Oh, yeah, we're about to turn it on. I'm going to put the plaster of Paris inside a vacuum chamber to try to remove all the bubbles. I probably won't get a full vacuum because there is water in there that will start to vaporize, but hopefully we'll get something out of this.
I gave you that vibrator multi-tool too. You can.
I was just thinking of that. I'm like, where's that vibrator multi-tool? Why isn't it ready? But unfortunately, I can't really do much because it's not ready.
Oh, yes.
We're pulling a vacuum on it. We are at coming up on negative 0.4.
Sweet. Pull that vacuum. Pull. Oh, electrets, guys. All these dudes have already heard all about electrets. They're already out. We got like 12.
Please give us
experts.
advice on electrets. We could use the advice. We need to know because we are struggling with the process and we're just getting started. I know it's a specific formula and it's got to be just right in order to get these things not to crack.
Post some papers. So like if you guys have any papers or any links to some stuff, helpful stuff, any literature, please send it along to. Why don't you give it to this address? Yeah, the alien scientist at gmail.com. I gotta check that out. So the alien scientist at gmail.com. You guys can send me some emails there if you guys if we have some experts on electrets.
Ron Kita is an electric expert.
Yeah, we got to get Ron Keita on here, man. Where's Ron? I want to get Ron on just for an individual interview, just to talk all about the whole. I don't know. I'd like to get him on just to film him, to put a documentary together, just to talk about everything. Oh, look at all the bubbles coming out of that, man. Look at it all. Yeah,
Oh,
pull that vacuum,
it's a
suck
big
all. Look at,
turn.
there's a ton of air in that. I never realized there was so much air, and it's gonna be dense as fuck.
Okay, we should probably stop
I
it
agree. Yeah, cut it off.
because a lot of that is also water.
So we're gonna rapid depressurize or devacuum.
Oh, wow.
This will pop all the bubbles and allow the material to come together. Another pole should equal much better degasification.
Regasification.
Thing is, there is water inside the plaster of Paris mixture, and that will start to bubble off too. So we got to be careful not to pull too much of a vacuum.
That's plaster of Paris in that mold, and there's a inside of that it's going to hold a dielectric material that they cast and are going to use for this experiment.
Yeah, for casting of an electret. We
An
plan on
electret.
casting a high temperature electret with acrylic. We might be able to use this setup for that as well. It's one of the things we're pretty excited about.
Yeah, in one of those 1951 papers that we were reading, it talks about using plexiglass, which is basically just acrylic. And they said that it was one of the materials that, when heated to its melting temperature and cooled under a high electric field externally, where it goes from melting to solid, it would maintain its dielectric polarization permanently. So acrylic is an easy way, and you guys can buy that at any kind of hardware store, Home Depot, Lowe's, or whatever. So that's something that we intend to test because it's readily available for everybody, and that would be a great way to replicate for something that everyone else can build.
Yeah. What's the what is the lid on that vacuum chamber made out of? Is that glass? Is that heavy duty glass?
Acrylic. It's 5/8 inch thick acrylic. It's been laser cut, which gives it a nice polished edge. They didn't bother to clean up after the laser cut because the cut edge is good enough. It has 2 holes drilled in the surface with some custom made fittings and a pressure gauge, and then dual release valves. So what they have on the intake, that's the blue valve there with the filter apparatus in front of it, that's to slow down the incoming airflow so that when you open up that blue valve, it doesn't blow everything inside the chamber around as the evacuated atmosphere suddenly intakes lots of new air molecules.
Yeah, once they suck all the air out, when you open that blue valve, it's going to introduce a lot of air right rapidly into that container.
So what Mark's doing basically is, because the bubbles have shifted the piece around on the inside, he's agitating it and getting it centered and just keeping things moving.
I'm just trying to get the bubbles to pop. Really, there's a lot of bubbles, and the plaster's starting to harden. So I think we're just gonna let the pressure back in, and we'll hope for the best in this cast. We'll know in a little bit how well it works.
I'm sure it's going to be a heck of a lot better than if you didn't pull a vacuum on it.
Yeah, I can agree with that. Okay.
Let's see what we have.
Yeah, to a couple people respond to it. Yeah, I'm not gonna waste my time on that in the chat. I'll type it.
I mean, any advice, no matter what form it's in, is good advice.
Pull that out. Put that down. Okay. There's not quite enough plaster of Paris to go to the top, but that's fine because I didn't really plan on making an the full size. I planned on making it about half size anyway.
This is actually going to be much easier to work with. You can take the, maybe glance it with the heat gun or a small torch to pop those bubbles if you want. But I don't think it's necessary.
So long as it's good along the surface, we should be fine.
Yeah.
Those are a lot of bubbles.
You can also stir it to mix them out.
That's true. Let me try that.
So is this this isn't related to the Podklitnov experiment. This is definitely for this is for testing electrets, and it's for testing it's for
Yeah, this is a dual application mold. So this is going to both be capable of testing electrets and allow us to cast a tapered dielectric material to properly test Thomas Townsend Brown. Now, let me talk just a little bit about T.T. Brown, because we made a mistake in the past, and we've been making a mistake for a very, very long time. If you read through T.T. Brown's lab notes, which you can find online, you will find that he uses several materials that he dopes his dielectrics with. So they're not just plain high K dielectrics. He talks about the necessity for finding the highest K dielectrics that he can get. In his time, those numbers weren't that great. What we have now, like the calcium copper titanate, incredibly high. Would have blown his mind if he had access to those materials. But in either case, one thing is consistent between all of his gravitator and gravity-producing cell and electrostatic generator systems, and that is he dopes all of his dielectrics with litharge, which is lead oxide. Now, what's so special about litharge? Well, he says that you need a high weight material, and it just so happens that he happened to find this one particular material which possesses the right properties when used in the system to operate correctly and produce this gravity effect. Not only does he use litharge, which is lead oxide, but he also uses lead plates as electrodes. So is there an interaction that's potentially happening here that we've been missing? It's very likely. I know a lot of people try to replicate T.T. Brown with wax and everything else, and they use, aluminum foil and common household materials, and we've done that and received a bunch of null results over the last 21 years. But now we're actually testing it based on his specific lab notes, and we think that litharge is one of those ways that we're going to get there, because we're doing what he said specifically he was doing. We'll use lead plates, we'll use all the exact same materials, as archaic as they may be, until we can get a reliable result.
And these are his original lab notes, right? This is because I feel like he was misled and did a lot of, I was real skeptical of his work in later years, and everything that I found on him at the Gray Barker Museum. But that's besides the point. That we're digging into pure science now, which is the important part, and doing experiments on stuff, because there's only one real way to tell. I really feel like and this is what you're trying to test with the Marx generator. You want to up the voltage to a much higher voltage, right? That's the idea. What you're doing with
impulse
that.
too. Impulse speed. Charge it in nanoseconds instead of
the impulse speed. You want that real fast gap.
Yeah, the speed is key with pulse power. Pulse power speed is everything. We were talking to Hathaway the other day, and man, is that guy brilliant. He was talking about a system he's working on using very fast-moving low viscosity oils in order to generate picosecond rise times in a very high voltage system. I have no idea how that thing works. I'm kind of blown away by the whole idea, but I can tell you I was impressed. And the idea of creating picosecond rise times is exactly what we need, because when we're talking about high impulse lasers, the National Ignition Facility, or just about anything that we're doing with gravity experiments, we need fast impulses.
Right.
And high energy level.
And how do you know it's picosecond? That's why we got to get that high speed camera, so that we can measure it exactly and know exactly how fast that.
Well, I called the high speed camera rental company the other day and left a message. They haven't gotten back to me yet.
Yeah, that would be something.
I mean, the high speed. Go ahead.
If we just had a high-speed camera and just did experiments with the high-speed camera, we'd get enough views on this channel. I feel like we could get 1 million subscribers on this channel just from that alone. But I don't know. It's
or maybe you're shadow banned. What about that?
The shadow ban, dude. We're just gonna keep working through it, dude. That's all. Let's just keep putting out content like this, and we're gonna keep putting out positive messages, and who cares about an occasional swear here or there. And I'm not gonna do more debunkings. I've already wasted enough time trying to show off who's a fraud out there, and all those. There's too many of them to really to bother with, and there's too much stuff to get involved with. You just end up wasting your time and giving them more attention that they don't deserve. That's the way I feel about it now at this point. It's like, be the change that you want to see in the community is really how I feel.
negative feedback is, is positive. Negative attention is also positive attention. That's what
Yes.
Trump worked off of. So, let's not talk about all the stuff that don't work. Talk about the stuff that possibly can work.
Yeah, I think that's why I've been unblocking a lot of the trolls too, like, and allowing them back just so that they, they can. It's time. I don't know, but
Oh, it's really bubbling now.
I feel like I've turned off a lot of people with my skepticism and the things I've said about certain people in the past, and I just want to I'm trying to turn over a new leaf with everything, and I'm not gonna spend too much time on the I'm gonna fight it in a different way. I'm not gonna try to battle all these people. I'm gonna try and show them look, this is really we got to work toward a common goal, and the common goal is we want to be flying around in these things, and we want to be respected by these things that are abducting people, and we want to be more than just we want to be recognized as more than just animals or lab experiments. We're guinea pigs to them, basically. We're a subwarp civilization. We're basically fair game, according to the Prime Directive, and according to if you believe any of this stuff about why I don't know, there's a lot of different theories of why that we have a Fermi paradox, why there's this high probability of extraterrestrial life out there, but this low evidence threshold, and it's because they don't want to interact with us because we're not advanced enough, and that's what we're trying to get to here. And hopefully we can, I've had to unlearn so much stuff, and then I've probably forgotten more than I could even remember at this point, but it's really about bringing new people into this so that we can educate the public about this and help get them involved, and then also find the people that do know tons about this or have better ideas to be like, oh well, look, let me come down there and help you, and you guys can be the star of the show for the week. That's what we want to do. Invite, if we want to get people out there that know cool stuff and can teach us some stuff, and them to come into the lab and really educate us. But I also want to be able to break this down for people so that everyone can understand it, and that we can have an audience that feels engaged, because there are people that are watching that really they have no idea, and I want to keep those people watching so that they can at least learn something and know that they're part of this too, even if they're not having readily having information. They might know somebody or might be able to share this with somebody who might be able to contribute, and that's important enough. Getting this information out to a larger audience and building this network for disclosure, because if we do come across something at one point in the lab and we want to show it off, we're going to need that big audience to be able to believe in this and to be able to share this information and what we're doing, and know that it's this is completely independent, and we're not working with any of these other groups or these other people. This is totally organic and grassroots funded, and you get on. It's really cool that all you guys are here right now in the chat, even though it's just 50 of you getting in on this grassroots level, because once this thing takes off and gets a bigger audience, we're going to start getting more people involved.
So basically, for everyone who just joined, what we're doing today is we're making electrodes. What an electrode is, it's basically analogous to a magnet. So a magnet has a permanent magnetic field or semi-permanent magnetic field, and the magnetic field, of course, orients the electrons in its surroundings. And what an electrode is, the same thing. It's just that instead of the magnetic field, you're dealing with the electric field. So what you want to do is get some material that can maintain its orientation, its electrical orientation, or its electrical potential through its subcritical temperature, meaning that you have it in its liquid state, and you apply a high voltage to it at or about the limits of the material, and then you allow it to slowly cool with that potential maintained. So that creates a stress on the material where it hardens in that electrical field, and the orientation of the subatomic or the particles, or the whatever the materials of the electrode is made out of, maintain their orientation, their electrical potential, and the object is sort of like a permanent static magnet. It has some pretty interesting characteristics. This was an electrode that we tried to make. As you can see over here, it has a crack in it, and we believe this happened because of the high voltage electric field was literally cracking the material as it came apart.
Yeah, let's take a look at the difference.
Here's one that we made without the electrical field applied to it, and you can see it's perfectly fine. This is the same composition of these two materials.
Exact same materials, cooled at the same time, in fact.
And this one came out perfectly, glossy and nice, no cracks, no nothing. This one had a high voltage applied to it, and the stresses of the high voltage actually created these little cracks in it. So what we need to do right now is find a way to allow the wax. We're using carnauba wax mixed with CTTO, which is a high K dielectric. And for those who don't know, high K means that the molecule's setup is in such a way that when it orients in one direction, it has a very high voltage potential, which is certain quartz have those orientation things as well, where you get the piezoelectric effect from.
Yeah, basically, it means that you have a lot of electrons on one side of the molecule, and you have a lot of lax of electrons on the other side of the molecule, but altogether the molecule is stable. So that if you apply a negative charge on one side of it and a positive charge on the other side, the side that has a positive charge will orient towards the negative charge, and the side that has extra electrons will orient towards the positive charge, and you can align these things with electric fields.
Yeah, that was a good explanation of it. Basically, it's a molecule that wants to orient with the electrical field, and the more unstable those two fields are, the higher the K value. And we're using calcium copper titanate, which is supposed to be one of the most unstable electric field molecules out there. And we mixed it in with the carnauba wax. Our first attempt yielded a crack while it was cooling.
You can pull that apart live on camera.
Okay, we're going to pull it apart and we're going to look at. Oh, wow, this is really interesting. Look at that.
So this is an interesting thing that we noticed in making other electrodes, and it's a very fascinating phenomena. And here's what it is. There is calcium copper titanate saturated in carnauba wax. Now here's what carnauba wax alone looks like. You see the color? You see that little disc inside where there's pure carnauba wax? Well, what actually happened is the electric fields pulled the higher K dielectric material out of the lower K dielectric material, displacing the lower K dielectric material, forming not only a layer on the bottom, but also a layer on the top, both directly above and below the two electrodes. And so we end up with this situation where the high K dielectric material does in fact follow the dielectric gradient between these two charged plates.
That is really interesting. It's actually separating outward. So we need some sort of binding agent to attach the CCTO better to the carnauba wax. There was recommendations to try mixing it with the other wax we have over here, paraffin wax, in order to give the carnauba wax better
mechanical properties.
Yeah, better mechanical properties.
We're going to start with 5% by weight, and then we're going to go up by 5% each time until we get the right mixture, because the key is paraffin wax is a soft wax, and it's soft even at room temperature. So the more paraffin we have by volume, it equals a bunch of dielectric dipoles that will be more easy to rotate and reorient themselves. And we want them to hold themselves in place. So we want the material to be as hard as possible, but still be able to maintain a cooling process.
For those who don't know, paraffin wax is what you have in most white, cheap candles, tea lights, or anything. It's a very common material, pretty cheap. Carnauba wax, on the other hand, is a little bit more expensive. You can make candles out of it. When you melt it, it has a really nice earthy smell that we're smelling here in the lab. And both these waxes are used in making of electrodes. Ron Kita is an expert in this field. We're trying to get him on the live stream tonight. But maybe if we can't, we'll get them on at a different time. Electrodes are pretty difficult to make, and there is not a lot of literature about them. One interesting thing about an electrode, like suppose this was actually a working electrode, it's not making free energy. So, because if you have an electrical field, you obviously have electrical potential. It's not doing that. What it's doing is, as you move objects closer or farther away, they orient themselves with the electric field, and that energy, that mechanical energy of moving a plate closer or farther away, actually turns into electricity.
Right.
So
it
I was
creates
thinking
a phenomena called electrostatic induction, which you can watch videos about on YouTube, and I would highly recommend it. Electrostatic induction requires no physical contact with the surfaces, but can actually orient their electric dipoles at a distance.
It's an amazing phenomenon. And something I was wondering about is, if we made a strong enough electret, would it be possible to make a thermoelectric converter? Because, you know, thermal is just the movement of molecules. So if we can get it to a level where the molecules shaking actually turns into an electrical field or potential, maybe we can get up from the 5-10% thermoelectric converters that we have today, you know, running the Mars missions, and, you know, get somewhere closer to 100%, which I believe is possible.
I have to talk about this.
Yes.
You weren't here for this, Mark, but and you missed it. Well, you were out picking out the phenomenal amounts of materials that we now have in the lab. Todd was on, and for those of you guys in the audience that don't know who Todd Seattle is, he's a brilliant guy, a researcher, an engineer, and an experimenter, and he's part of our experimental group right now, constantly contributing and giving his ideas. He recently spoke at APEC, and he also spoke at Estes Park. And today on a Zoom call, we were talking about some of the stuff that he did, and he mentioned something very interesting, which I want to share with you guys out there, because I thought, wow, that's phenomenal. He, based on a recommendation from Mr. Woodward, Todd took some of his Steiner Martin's 111 piezoelectric transducers and tried to dry them out in the oven. But when he went to take them out of the oven, he got quite a shock. It turns out that placing them in the oven caused him to charge up a reasonable potential, to the point that he could see electric discharge between a aluminum foil plate placed on top and one placed on the bottom. So something very interesting to consider when you're talking about piezoelectrics and thermal properties is that apparently heating these things up in the oven charged them up. So maybe there is a connection there that we can utilize for energy production.
A thermoelectric converter. What we're talking about is taking thermal heat and turning it directly into electricity. Normally what we're doing in power plants right now is we're using steam to run a turbine. It's pretty much 19th century technology. All runs on steam. But when you're out in outer space, you can't really do that, you know, because there's a ton of extra heat. You have nowhere to throw the extra heat, but you need something that's much more efficient for a thermoelectric converter. So if you can do that with piezoelectrics, that would be very interesting.
Sure would be.
I wonder how efficient it is at like how much energy you can actually suck out of it.
Well, so far the only reference I've ever heard was Todd talking about a strange observation that he made in the lab, and as a good scientist, made a mental note of it.
Getting back to thermoelectric converters, I actually had a conversation a couple of years ago with a PhD grad student who wanted to use thermoelectric converters on a hybrid, because I work with hybrid batteries, and he wanted to suck out the extra energy that was coming out of the exhaust and use it to charge the hybrid battery. He calculated that at most he'd be able to get maybe like 100 watts out, but he was doing his dissertation for his PhD, and I urged him to look further into the field, because I think it's going to be major breakthroughs are going to be made in thermoelectric converters.
Yeah, there's going to be major breakthroughs made in magnetohydrodynamic converters as well. That's something that I've recently seen, and I seen a steam power plant augmentation. It was a whole paper written about a steam power plant augmentation where they decided to, on the intake system going to the turbine after the coal burner, they put an MHD electric converter in that took all the free ions that were both positive and negative from the process of coal burning, and through a very, very strong magnetic field, collected those charges on the ions and powered it. And it turns out that they got more power out of the MHD system than they get out of the steam converter I think it was 4 megawatts out of the MHD converter and 1 megawatt out of the steam converter. I could be wrong on that exact number, but it was a huge number. And that just speaks volumes to the idea of using the electrical and magnetic properties of burning a fuel in comparison to using their thermal expansion properties to drive mechanical systems like turbines. It's something that's coming, and it's being worked on right now at multiple universities across the United States, Canada, and several other first world countries.
Should I clear off the whiteboard?
No, definitely not. We don't need to use that right now, but we do need to leave it like it is.
I was thinking of a presentation on it. I could take a
No,
picture of
not
this.
right now. What you should do is show all the stuff that you just picked up.
Oh, okay. Why don't you grab that? Yeah, we just spent $150 at a dollar store getting a whole bunch of stuff for the lab. Now, you guys walk into a dollar store and you're thinking, yeah, let's buy some junk for the house. But
Which one was
Look at
it? Dollar Tree, Dollar General? What was it?
yeah, Dollar Tree. You've been there. These great dielectric material. Dielectric, of course, means that electricity does not pass through it. So we can use these to
Insulator.
Yeah, an electrical insulator. Pens, of course, we need pens. You were asking for some ladles earlier. We got all different
Yes,
kind
to mix up dielectric materials in various mixtures.
This is actually one of the reasons why I went to the dollar store in the first place. This is to close baggies of the highly toxic powders we have here in the lab. Make sure that they don't open up by accident. And we, of course, we're double bagging everything, but I want to have these, just in case. We got some more bags. We got some cups. What else do we have over here? Spray lubricant. These are chill packs because a lot of the stuff we do involves temperature. Just some clips to hold stuff together. And
useful for high voltage leads.
oh, this is for the toaster oven.
Awesome. We needed that.
Oh, and this is something that was pretty important. We have some materials that will get damaged from moisture, especially the superconductors. So we're going to use this inside the baggie with the superconductors to keep them dry.
A nice pre-dried desiccant in a plastic seal.
Yes, that is very important.
If anybody here has worked with superconductors, you probably are already aware that superconductors degrade over time naturally, and the primary reason is moisture absorption. So keeping them in a desiccant is a great way to store them for longer at room temperature.
Dog bowl, not for the dog. This is for, it's another way that we can create an electret, or have a metal bowl handy is always good, but we could put different materials here, ground this out, and have the electret on top of it, and put the high voltage potential over here in order to create an electret that way. It's always good to have extra bowls around because there's a lot of mixing and stuff that we'll be doing here in the lab.
We'll be showing you how to build a UFO out of a dog bowl from Dollar Tree.
That's no lie.
Oh no, we're not making any UFOs.
I'm just kidding. It's
not a
it's
UFO,
funny
that's
for
good.
everyone that just joined in.
It's
That'd be awesome.
identified.
No, we're trying to make.
We're
flying
gonna
saucers.
how to send your dog to space.
We're trying to.
Cosmo.
We're trying to make interstellar spacecraft or FTL spacecraft. They're plastic plates. Why do we use plastic? Again, it's a dielectric material.
And it doesn't absorb CCTO or other powders
And-
specifically, and it doesn't react with them.
It's also slightly flexible, which is a good thing. Because, like, if you're making if you're casting something, you want to be able to flex it a little bit to remove it from the cast holder. Over here, we have, these are going to be good for picking up the superconductor or anything that we want to pick up that we don't want to touch directly. They're metal, little mixing bowls, and these are shakers. Why do we need shakers? Well, you can put iron powder in them and just shake it over the aluminum sample.
Make sure you mark it so I don't like shake some barium titanate or some iron flakes on my.
Jeremiah's in charge of that. We decided he has
Everything is marked.
a
Must be labeled. It's a scientific requirement of our lab, and
Yeah,
you can
yeah.
see proof of that all the way around. Everything has to be labeled. I'm a big fan of knowing where to read the box to find the thing I'm looking for, so that my brain doesn't have to log every single thing all the time continuously.
And what you're seeing over there is all Jeremiah's handwriting because we decided he has the best handwriting for it. Coconut oil. Why did I get coconut oil?
It can thin certain waxes or various other
It's
materials.
really good for your
Oh, maybe
skin.
we can make an electrode out of it. What kind of molecule does it have? I don't know, but for $1, we can find out whether it makes a good electrode.
Yeah, that's the highly saturated one too. That's why it's quite solid and also opaque with a slightly yellowish hue at room temperature.
Yeah,
So-
it's slightly like cracking and stuff, but we could
Yeah,
try
that's
different.
going to be ideal actually for what we're doing. There are several grades of coconut oil. Super purified coconut oil will probably be liquid even at this temperature, but that will actually suit our purposes quite well.
You got to lube,
Yeah.
lube yourself up with that before you go in the Faraday cage, you know.
Only the hinges, unless you want to get trapped inside the Faraday cage, which would be a particularly bad situation since you can't make a cell phone call out of there to call for help.
Right.
What else
You
did
just
we
get fried alive.
Yeah,
Right
just
alive.
It's like an
I would-
electric chair. With that.
Hung on the walls.
a whole bunch of duct tape and some random cords. You got a toothbrush, of course, is good for mechanically removing stuff. This one is coated with charcoal, otherwise known as carbon. So I don't know if that has any special properties that might be helpful to us. Of course, a magnet picker upper and some brushes. Oh, I was looking for a couple mirrors. These are going to be useful for the results. When you stick this in the bucket of water, or we can shine a laser on it. We want different kind of mirrors set up so we can see if there's any reactions.
Hey, you know what I'm gonna bring to the lab that I got actually? You know those
Fire
big
bread.
you know those big projection TVs, the old school big widescreen TVs, you know, before they had the LCD and flat screen.
Rear projection, right?
Right, they have a giant Fresnel lens in them. I have a 52-inch
Yes.
Fresnel lens, dude. I gotta bring that down. You guys can.
We built 3 of those things out of garbage we found in Milwaukee. We built some massive magnifiers that were melting stones and stuff on camera.
Yeah, you
But
can
anyway,
forge
one
steel
too.
with the fucking thing, dude. It's in
can.
sunlight because it concentrates so much sun energy like into a single spot. It gets so fucking hot. I gotta bring that down to the lab. We gotta do some experiments with that, especially in the sun. I wanna start melting all the snow with it, and it'd be awesome.
Scissors,
Thank you.
and all different plastic spatulas. Oh, look, these are the silicone spoons I talked about.
Those are interesting. Are they pure silicone?
I had this
Oh,
idea about like a future society where like
backbone to it.
Oh, cool. It'll still work.
Yeah, for high temperature
Yeah.
mixing and stuff. So
sorry.
decided to take lots of stuff. There's a lot of stuff you can find at a dollar store can really help you in a lab. It's pretty interesting.
You needed that trip to the Dollar Tree just to buy like that closet full of junk, and I gotta get that bathroom put back together so we can organize like some of that stuff too. Jesus, so much work to do.
They're ancillary lab materials.
Oh my God, you created anti-gravity. Oh wait, yeah.
That's right. That's
I
how we
thought
do it
you-
here
I
in the
thought
lab.
You're all upside
They're
down.
ancillary materials, and you need them in order to do these experiments. I mean, sometimes having something as simple as a pen and a piece of paper is kind of necessary. So just having this stuff around to be able to work with and not be stuck because we're lacking the right type of container to mix something in, or we're lacking a spoon that doesn't melt under the heat gun. I mean, it seems like simple stuff, but without that, it becomes rather difficult to do experiments. And you're basically in your garage lab asking yourself the question, do I dare use my family's cookware and possibly get in a fight with my wife in order to do my anti-gravity experiment? So that's why all this stuff is kind of important,
Yeah, it's dollar throwaway stuff. It's like, who cares if you wreck it because it's just $1, right? It's
Right,
just Dollar
exactly.
Tree.
Dollar store anti-gravity.
Right,
Welcome
and it's
back,
for the and you know what, it's a willing sacrifice we're willing to make, if it's like a couple dollars, because we'll get $20 on that video like we just got from. Let me just give a shout out to, we got a live chat, we did make $20 here in the here on the live chat, and I want to shout it out. It was Chris Bounds, and he asked the best way to contact us, and I posted that for him. Thank you for that $20 that will help go towards new spoons and dog bowls for,
Jeremy, are we going to hear your song yet?
I don't know. I don't have like a real, what did we even come up with? I forget now. Jesus.
Tom.
Yeah, right. We were gonna make a song about Tom DeLonge, and and TTSA and what we're doing and like where the heck is your spaceship? And
Where the heck is your spaceship?
no, you ready? Here. I was gonna do like. Somebody once told me you can't have anti-gravity. You ain't the sharpest tool in the shed. He was looking kinda dumb with his finger and his thumb in the shape of an L on his forehead. Well, he went on Joe Rogan and he saw it coming. Made a fool out of himself with 1.7 million. And didn't make sense, real. Not to live for fun. Your brain gets smart, but your head gets dumb. Too many experiments to do. Sitting here with the lab and my crew, trying to come up with jams. And watching TTSA. Hey now, you're a rock star.
Hey, Tom.
Oh yeah, it was. Hey Tom, you were a rock star, but you put a tie on, and you teamed up with TTSA. Hey now, you were a rock star. With Blink 182, and then you joined the CIA. All that glitters is gold. Only shooting stars.
Only rock stars.
Jeremy's taking donations for better lyrics.
Yes.
Your recommendation.
Please help me write this song. We're gonna come up with a funny ass song about this, right? Fair use. It's fair use, guys. I learned that song because my kid loves Shrek, and it was the Shrek song. That's what he knows it as. So it's a song that 4-year-olds listen to. He doesn't know the words yet, but that's all right. Neither do I fully. We just make them up as we go, right?
That's how we do it. Except for with the experiments. Those we kind of figure out before we do them.
Nah, we listen to the pros, man.
After we do them and they screw up.
I listen to the pros, I'm not like, I never had a recording label. I could make up funny songs, but it'd be like more like Weird Al Yankovic than it would be like, anything serious. Cause
if you like Weird Al, you're doing pretty good.
Weird Al was all right. There's some funnier people out there too that make up stuff. But in any case, on a serious note, I like what you guys are doing with the Dollar Tree, mixing bowls and measuring cups and spoons and stuff. And
you guys want to talk about more serious stuff?
I do, man.
Wow.
Good. Well, let's get on to that. Okay, so here we go.
We'll cover a Blink 182 song, but it'd be too annoying.
Yeah. Well, let's take a look at this. This is a little bit more serious stuff.
Holy shnikes!
I spent all last night putting this thing together, straightening out the resistor chains, resoldering every connection, smoothing them out, making all the wires exactly the same, just making sure that the inductance over each capacitive circuit, where we have 2 parallel capacitors per stage, is basically balanced. And it's on this massive 7-foot tall rack. Now this is only half the chip. So this is already pushing nearly 500,000 volts as it is.
Oh, this thing is scary.
Of God.
We do not dare power that thing up alone. We actually have a.
Yeah, let's talk about our lab safety. There is, and Mark went ahead and equipped it with AED, which we are trained on, just in case.
This Mark's generator is no joke. This thing is pretty dangerous. When it puts out 1 million volts, that thing can spark 4 feet. It can hit the ceiling for all we know.
Yo, we should put a monolith somewhere and send lightning bolts.
Oh, I posted that on our Facebook account. We got a monolith in the lab, and everyone
This is the real monolith.
This is the real this is the monolith that counts. Look at that.
That's a
you guys,
monolith.
we got to be careful, man. With that monolith, might be giving off friggin' some serious X-rays, and we
It
might.
will be giving off X-rays for
yes, it
sure. That's
will.
why we run the test in a different room, and we have a bunch of cams
Holy
to
shit!
watch this experiment take place. But one thing we really do need to look through, at least live with the window at the minimum, is the discharge, because the discharge for the Pakhanov impulse gravity experiment is very critical. The shape of the discharge specifically is critical. It needs to come off the surface of the superconductor almost as if it's a cylinder extending from it. So those of you who do 3D modeling and you sort of extend a cylinder out, that's basically what the beam is supposed to look like, as this glowing plasma that shoots straight off the center in a fairly symmetric and coherent way and then strikes the target plate at whatever distance you have it separated inside of your evacuated chamber. And if we don't see that characteristic type of discharge, according to Pakhtanov's papers, any discharge they did in the vacuum that didn't have that type of geometry that was very symmetrical would not produce the gravity impulse. So it's something that we're specifically looking for, and we would consider it a bare minimum to say that we had successfully replicated the experiment.
Yeah, so one of the things we want to do is create like some really, really fine mesh that we can put around these cameras to kind of insulate them and create Faraday cages around our cameras and our recording gear for our lab setup. That's going to be part of what I want to set up when I come down there and build, because my goal is to get our lab set up for media, because media is really what I'm concerned with, is getting better quality video, better quality, keeping the video and the audio quality up to standards for our audience, to keep our audience interested, to keep people watching. That's kind of been my goal with this, in addition to a lot of other things. But yeah, so I want to get this lab set up with some cameras that we can get, and it's important. And we're gonna have to keep those babies insulated with this kind of series voltage going around. That's incredible. And the next thing I want to do, we got to get a CNC. I want to get
a CNC. We're not going to do, because that actually takes up a lot of space, and we have one next door, and the guy's willing to help us out. So
right, they got that machine shop next door. We should outsource as much of machine shop stuff as we can. That way we don't need all that stuff necessarily on hand here at our lab, but we can outsource certainly a lot of that.
You were talking about shielding the cameras. Let me show you what we have planned for that. So for shielding a camera, one idea we had was to use silver, very fine mesh. We could stick this right up against the camera, or the lens. And I'm going to show you right now what exactly that would look like. There you go. Well, it's minus the bag, but if you got it in close enough, it might be possible to remove the glare. Let me actually.
Yeah, you're talking about a very, very small millimeter camera here, which is going to make that grid look huge. But on the aperture of a GoPro, which is much wider,
it looks a bit better now without that. But
it looks a lot worse because you guys are looking at this through a MacBook webcam. But when you talk about the wide aperture of a GoPro with its fisheye lens, that grading basically just becomes a slight darkening of the total light that's entering the lens, and you don't really see it anymore.
We could actually try that right now with our GoPro. Let me.
You know what also might be an easier way to shield it is to put a bunch of lightning rods just around the general vicinity, because
that won't stop high-speed electric fields or high-speed magnetic fields, though. That will only stop.
That's true. It will just stop. Yeah, arcing. Yeah. Shit.
Oh, here, we're gonna turn this on. Now you can still see it.
Can you focus out of it, though? Or is it trying to focus on the closest object, because it does have a macro setting?
You know what? We might have to invest in some cameras that we can just...
like that. Yeah, see, now it's focusing on the bench. Now it's working. But when it's too close to your face, it's not focusing on that.
I think it's the light is hitting the...
I think also
we should appeal to some of the webcam companies and be like, do you want high voltage testing for your webcams? Because we'll do it for free. You know?
Get it out of the
and we'll just use theirs, and we'll be like, all right. You know, it looks like the so and so is the leader. Their camera's held up to, like, you know.
Yeah, that's working. That's plenty good enough to be able to see a video through, especially if we control lighting. Right now, you're seeing glare off the screen itself. That's because it's directly underneath the light source. But honestly, if this camera is in a dark
Oh,
box.
Tech Planet from
No,
the chat says look up Faraday fabric. It's a coated MXene. MXene.
Yeah.
I don't know.
Faraday fabric.
Faraday
Oh, yeah,
fabric. Thank you for the
we
tip.
have that. We actually have some of that. It's silver coated nylon. That is very useful for making clothing. And that's what the extraterrestrials are wearing when you see them all in silverish clothes. It's probably some sort of Faraday clothing. Actually, it's right over here. This is it.
All right.
Almost like
So
Yeah,
All right.
I can't speak on that, but I can say we tested the Faraday fabric in front of the cameras, and I can tell you that the screen door effect is significantly more noticeable with that stuff.
Felix Audet at it asked, "What happens when we get anti-gravity? Will NASA shut us down? Do we have a plan for that?"
Yes, we do. Mass distribution of the technology.
Yeah, man. Like you, the plan is that you email me right now at thealienscientist@gmail.com and you say, "Dude, like, save me and put me on the list." And the deal is that when we're gonna start a newsletter, I'm gonna get everyone on that email list soon, and I don't want to start an email list because I don't want to just get people bored with shit, until we have something real to send out. So I might send out like a test email list, but basically you basically if you email me, you're going to get put on the distribution list so that when we do get something and it's ready to go and I'm like, and it's really exciting and it's serious, you're going to get it's going to get sent out to everybody all at once from multiple email addresses. So that's the kind of the plan is that we're creating a network to distribute this, and just creating the network also sharing this and getting other people interested and involved with what we're doing is also helping us build the network and build momentum for this so that they can't shut it down, so that NASA has no choice. They won't be able to beat us. They'll be forced to join us.
Well, NASA actually, many NASA engineers were on the APEC conference, and I think some of them actually gave speeches and gave us some useful advice. What's his name?
There's a couple guys from ST
Murray.
Spark and stuff, that have done tons of work for NASA. So it's not that we're fighting against these people, really. It's that we want to work with them. It's that we understand the bureaucracy of government. It sucks. We all fucking hate it. Everyone's living in that. It's the system and the gears that we're forced to live in, and we as humans need to figure out a way to, circumvent these and create new systems, new things that are new ideas that are going to work. This is the future. These Zoom conferences and these interactive webinars that we're trying to set up is going to be the new way of doing science. It's going to be the new way of doing discovery. It's going to be the new way of doing open R&D. That's what we're hoping to set up with this.
There's a new idea: open research and development, letting everybody see your mistakes as they happen.
Yes.
How about that?
Yes, absolutely. It's just Solar Marshall's in the house. What's up, guy? Thank you for joining us. It's openly broadcasting, and part of this is fail forward research. That's why Wayne's. I love his motto, his name of his group, fail forward, because we need to just keep. We need to really, in order to. There's too many frauds out there, for one, and it's just there's too many people parading around with shit that's not fake. It's not real, and we need to sort it out and really break down this stuff and do it the right way, not do it half-ass. Dig in and make sure that we didn't try that yet. Let's go back and try it again. We don't claim that we've done this. We try everything, and we do it exhaustively, leaving no stone unturned.
We don't claim to know ahead of time. We don't claim that we're right or that we have the answer. We don't make any claims at all, in fact, except for the one claim that we do make, which is we're going to try to do these experiments as faithfully and accurately in the same way that the original engineers and experimenters did them, because we don't know what we're looking for and we don't want to make changes until we have an answer. So that's the one thing that we do claim. But other than that, we're prescribed to no particular theory and no particular view.
Nope. No, it's just inviting the conferences. We're inviting these people to come and present their knowledge, their information, and their ideas. And then it's our job to basically try to sift through this and engineer details out of this that we can build in our lab, and then get as much help from you, the public, as possible. And that's how this is all going to work with open R&D, and that's how it's going to be like the new Manhattan Project, but it's not top secret. It's just out there for everyone to help out with and see and engage with and help us out with.
So what would be the opposite of top secret? Top public? Are we top public yet?
No,
I mean,
we're not top public, man. We're not pop culture because we're not like, Kardashian. That's like top public, I would say. Kardashian level is like,
Give it time.
if we had that.
If it becomes important, then it becomes $1 trillion industry. I mean, hey, the first guy that asteroid mines.
I can't say that, dude. Our reality TV show has got to be more interesting than those people, man. I swear. We're funny. We're friggin' human. We just need like fake asses and plastic surgery, I guess.
I think what we need is accurate results, good data, and quality reporting. And if we get those things in line and we actually have results that matter, that's all we need. The rest will come.
Yes, just give it time and just keep doing the hard, honest work on all this, and we'll keep posting stuff as we get it. I want to make short, condensed summaries of all the different experiments that we try. Afterwards, we'll do a whole special on TT Brown where we show everything, and I just want a summary of all the different shapes, sizes, different discs, different dielectrics, different materials, different things, all the different, a whole smorgasbord and array and assortment of different tests and what the results were. No. Document and show all the failure.
You have to leave a cliffhanger on each episode showing one that actually worked.
Yeah, there we go. One that actually worked on each episode. That'll be the day.
At the very end, the cliffhanger to keep them interested.
Right. We'll show them that we have the one that works, right? You got to have that TV show where it's like, we'll see. Is it the one on this? Is it on this episode that they figure it out? No. It's like the reality TV show that we could make out of this if we had the right producers and the team that, we got to pitch this to Netflix, dude. Be like, yeah, you guys got to get a crew on this. For real, I'm not doing this justice. Yo, Felix Audette said he has a ton of ideas and half-baked ideas for us. Dude, pull up a fucking table.
Both those. Yes, absolutely.
Yes, grab a beer, light up a fucking bowl or whatever you want to smoke.
Zoom call.
Yeah. Yo, who wants to... should I open this Zoom call up?
Dude, yeah. Chris, are you okay with that?
Who's down?
I see behind your keyboard.
Go download Zoom and get the updated version on your computer now, because I'm about to post this link. I'm about to open it up. I'll just find someone who's in charge that can kick people out and moderate for me,
We're in charge over here. We could kick them out.
I'm not an expert.
Yeah, if we get any real trolls or anyone
Sure.
Yeah, we're just organizing here in the lab.
we got at least 2 agents watching every live stream we do. There's
I would hope.
if we don't, then they're fucking stupid and they don't know what the hell they're doing.
They're not doing their job.
They're not doing your job. Because this is where all the real shit happens.
Poor agent. Gotta play more songs for the agents.
Dude, they love my shit. I think Bob Lazar is in the chat.
All I know is that I'm gonna wake up in the morning, and get me some superconductors and some liquid nitrogen.
Yes, dude. Every morning, I wake up.
Every morning.
My 3 little birds. Yo, so who You guys ready? I'm gonna go grab a beer, and then I'm gonna open this up. I'm gonna post that link in the live stream here, or someone else can do it if they want to. It's we got 66 viewers. Oh my God, we're gonna seriously open it up. Who else does this? Who else does this shit, dude? Nobody else on the internet that I've ever seen like is real enough to like host a live stream and then open it up to their viewers. John Brennan comments. Oh yeah. Did you guys hear the John Brennan, the CIA director, talking about aliens? Did you guys watch
No.
that?
No, I didn't.
You guys didn't hear that yet?
More and more every day.
More shit is coming out every day, dude. I don't know. This ain't real shit though. This is just the CIA. You can't trust nothing these people say. All right, let's do John Brennan, CIA, aliens. He was on some podcast or something, and the dude asks him about aliens, and he's like talking about the Nimitz tapes and how they were intriguing. They couldn't explain what they were, and you know, all that bullshit. Nothing about the... Oh, yeah, here we go. Deep State Journalist is live right now, I guess. No, it was 2 hours ago. Oh, he started streaming 2 hours ago. Is he live still? Yeah, he's got like 2,000 people watching him right now. It's no wonder we don't have anybody watching us right now. Holy shit.
Not mine.
Hey, Dan, what's up?
I downloaded Zoom. Okay. It's asking me to launch a meeting. How do I get in with you guys? What's the name of your?
Yeah, I'm gonna post it in the live chat right in a second. Right now, let me go and guys, give me the link to the live chat. I'm gonna post it and so people can start joining on here. Dude, there's 2,000 people watching live on watching Dark Journalist live, so that's why we're not. That's insane. He gets a ton of people watching him, man.
Yeah, but he's not doing live gravity experiments, though, is he?
No, he's not doing live gravity experiments at all.
Nobody is. Oh, except for us.
Like I said, Bob Lazar's trolling in the chat. I got a message.
Oh yeah, huh?
Anyway, all right, I'll wait till you get. I'll figure this out. I downloaded Zoom. I hope I have the right thing. It's Zoom.us.
Why don't you just go in the...
So I wanted to ask you.
Where'd you guys send me the link to join this? Did you email it to me?
I emailed it to you, and it's also on our Falcon Space WhatsApp group.
All right, I'm gonna go check my email and I'm gonna post this in the live chat in just a second. You guys are.
You have to just send it to me on Messenger or text it to me. Send it to me on Messenger if you have to.
All right, here's the link. All right, can I just post this link?
Yeah, go ahead.
I can help moderate too if you want.
All right, we're about to open this up. All right, you guys ready? Ready for the onslaught? Here it goes. I'm posting it right now. Here goes nothing.
Nope, not at all.
How about all this stuff?
Yo, click that link and you'll be in the Zoom call. If you click that link, you can join the Zoom call. But they have to let you in, so the moderator will have to keep an eye out for those people and let them in as they come. And kick people out as they deserve to be. I'm going to go get a beer. This is going to be awesome. Nobody else is doing live experiments and engaging the audience live, dude. Nobody else is doing this. And once we start getting more people involved in this, it's only going to get better. I can't wait to get Eric Davis on and some of these other guys. Man, if we can get Hal Puthoff on, that would really give TTSA some more, you know, I don't know, man. They've just like done so little and been drip. We've all been like, what the hell, dude? There's so much more information than these people are letting out. Anyone who's been, researching this and has, knows what I know is just, I'm just screaming out like, man, like this information needs to get out to the public. My God, like, why is nobody talking about all these papers and all this science and all this physics and all this research? Someone's got to do this. Someone has to lead this and be this guiding light, and nobody else is doing it. So that's what what we decided to do, man, pull this team together, and we're trying to get the best of the best and encourage more people to join on and join up with us who have this vision, who have resources and the ability to make this happen, because it's the only way we're going to get off this planet. It's the only way we're going to show the Galactic Federation, if it exists at all, that we are worthy of a spot among the stars with the rest of the aliens, with the rest of the humanoids.
We're the men in white to counter the men in black.
Right. This is the men in white. This is our response to the men in black. Yeah, man, it'd be great to get anybody on that knows anything about reverse engineering alien technology, that for real, anyone real who can demonstrate the physics, who can back it up with math and really educate the public on concepts and ideas, which is, we're learning so much from having these old timers on, to really show us like everything that's been tried already and really educate us on this, because there's so many misconceptions out there, I feel, about what has been figured out and what the government really knows. And how do you know what the government really knows? Well, you just talk to the best scientists that the government talks to, the people that they talk to learn all the answers. And this is there's no better way to really cut through the bullshit and this conspiracy stuff and really find out what the government knows, where the answers are, and where the cutting edge of the information is in this right now, currently. Is that all right? You guys, am I talking nonsense here? I'm gonna go grab a beer. I think I need more beer. I deserve one after this. Shit, 1,000 playbacks, man. Look at how many people clicked on this and then clicked off, man. What the heck?
That's weird.
Weird. I don't know what's going on.
Yeah, we got some dry spells here and there.
Oh, that's mixing in pretty good. See how 4 grams of wax added to this 38.5 grams of CCTO and carnauba mixed well. We'll see if this prevents it from cracking. Otherwise, I have another 4-gram piece set to the side. And we'll get this mixture right.
Lab take over here.
Just fucking coughing.
Carnauba is a rather pleasant.
We gotta make more songs making fun of Tom DeLonge. I heard he's in the chat right now watching live. All the wrong things. Why is nobody joining this chat? Is this the wrong link? Did we get the link to Zoom?
You should have. Let me see if I can share it with you.
I think that's the right link. I posted it. Nobody's joining this shit. I don't see nobody.
How long have you been live now?
I've been live for an hour and a half, an hour and 27 minutes, bro.
Jeremy, I just posted it in the chat here on Zoom. You can pull that up and send that one. That's the correct link.
All right, that's the link I've been posting, I'm pretty sure. Why isn't it posting? God damn it. I'm going to post it in the description, guys. You ready? It's in the description of the video. I'm posting it. I just saved it. It's in the description of the video. I just posted it in the chat like 3 times, and I guess it didn't appear. So I don't know why. Maybe it doesn't do it for some reason. So I posted it in the description of the video, so hopefully you guys can find it through that. I don't know why it's not working.
I just removed that afterward. What else? Jeremiah is mixing up. Oh, we just got Felix on. Hey, Felix.
Felix. All right, Felix, what do you got in your bag of tricks?
Can you hear me, Jer?
Oh, this is what's up, dude. We're going to have
What's
quickly
up?
like
What's up,
30,
guys?
30, 70 people in the call. Oh, my God. What
Awesome.
All of a sudden, Jeremy, everybody comes on all at once. It's
Great.
awesome.
This is awesome.
We want to talk about some hive mind stuff. Everybody, all at once.
Oh, my God, everybody.
Great. Hey, guys.
Just mute your mic if you're not talking, please, so we can get some incoming internet people.
Thanks for the cam, Aiden.
Yes. Welcome. Greetings.
Is there a separate screen? I'm really confused here. Can you hear me, Jeremy?
I can hear you, dude. You're live.
So do we watch the YouTube screen? There's no separate screen for the Zoom meeting?
All right,
Is
just
that how this works?
pretend there's a whole bunch of Pentagon people here and a bunch of people, aliens from the Galactic Federation. And
I landed in a TR-3B, bro.
Listen, let's just talk like real serious and
Yeah,
like
I'm good, man.
I'm not kidding around, man.
What do you guys recommend as far as the download center? You have like 4 or 5 different types of downloads. You have a Zoom client for meetings, a Zoom plugin for Microsoft, a Zoom plugin for IBM Notes. Like here's probably the one I need for extensions. One for Chrome and one for Firefox. That's probably what I'll go with. Yeah. Let me.
Oh my God! Instant pandemonium. This is going to be insanity now. All right. Let's try this.
I'm glad to be here, man.
Yeah. So welcome everyone. Anyone who has something to share, all you got to do is raise your hand, and we'll let you speak and present, man. And welcome to the group, and welcome to the future of humanity.
I want to say something, man.
Yeah. Go ahead. You got the mic.
Yeah, I'm going to come down and meet Jeremiah and Mark one of these days. As you guys know, I've known Jeremy for over 10 years now. We've done research for forever, Jeremy. You know, think about how long it's been. Jeremiah, man, you kick butt, dude. I've been watching you. Yeah, I have an electronics background, and man, I listen to you talk, and I'm lost. And that doesn't happen usually.
I don't hear any compliments, so that's really awesome.
Well, that doesn't happen usually, but I told Jeremy, I mean, with you and Mark and Jeremy, you guys got the right team together.
I think so, man. Like, Jeremy knows his media. Mark is a guy that gets her done, and he'll do like literally anything that none of us would ever dare do to move things forward. I'm the engineer and, you know, the guy with the crazy background with calibration and all that other stuff. So I try to make things happen with other people's ideas, but you know, I try to stay neutral personally, so I can talk about that because I'm not saying for anybody else.
Engineer.
Oh, are you an engineer too, Mark? I wanted to ask you guys where you guys went to school at, if you didn't mind, or you don't want to reveal that. I get it.
Both me and Jeremiah learned all this stuff on the fly. We haven't really gone to school for this stuff, but
Yeah,
that's
I
kind of
taught
how
college kids. I mean, I did teach college students the engineering stuff, but honestly, my weakness, and publicly putting it out there, my weakness is mathematics, and your weakness is people skills.
I learned most of my electronics, even though I have a degree. I learned a lot of it on the job with guys that were geniuses that picked this stuff up like it was water. You've always got that one guy that just he looks at an electronic circuit with 10,000 parts on it and three or four schematics for that one circuit board, and the whole thing just makes sense to him. I learned from a lot of guys like that, old school guys that didn't go to school at all. And
well, look at Elon Musk. He doesn't care if you have a degree or not. He'll hire anyone as long as they can do the job and they know their shit. You you know.
Oh, there's savants out there that are just geniuses, you know.
Well, my dad worked
amazing.
at a company. I worked at this company too. It was the Foxborough company. They did automation controls and parts and stuff for years. And when they got bought out by a foreign company called Invensis, they came and did an overhaul where they had these, you know, people. They fired anyone who didn't have a degree, and they lost some of their best people, and they weren't able to really function as a company for a number of years because these audits, they wanted to get rid of all the people that didn't have degrees and stuff, and these were the best people in the damn company.
You're darn right. I've seen. Well, I'm an industrial electrician too, so I do a lot of 480 stuff, and my end of the business moved from circuit boards to industrial for the simple fact that, as you know, most of the circuit boards and stuff like that, when we moved on to surface mount instead of through-hole technology, a lot of it left the United States and went overseas overnight. So I was like scrambling for jobs. I was working at one place till they closed, worked at Honeywell till they closed. Literally overnight, the circuit board industry dried up. And it was a shame because it was good money and it was fun. But I switched to being an industrial electrician about 10 years ago, actually longer ago than that. But yeah, man, I want to come down to the lab. You know, Jeremy's invited me down a bunch of times. I don't live that far. I'm in PA.
We'd love to have
Would
you.
be cool. Yeah, man, it'd be cool. I'd love to come down there and hang out with you and Mark. I mean, I'll probably never leave.
I'm not here all the time, but Mark is pretty much, you know, around all the time. I'm in from Milwaukee just for the month. I'm leaving back early next month, but I'll be back and forth between here and Milwaukee because I have my own lab set up out there and obligations there.
So you're near the Harley plant, huh?
Oh, very, very close. I've calibrated the Harley plant.
Oh, have you?
I have.
No way.
love their
Did they ever
machining.
send you to the York division in PA?
No, we never did that wide of a
Yeah, I
coverage.
worked
area.
at the
We
York
only did
division.
Tri-state area.
Yeah, I worked at the York division. That's the assembly plant. People don't realize that the transmissions and the motors are made in Milwaukee. The bikes are built in York, PA. A lot of people don't realize that. The main
Well, not a lot of
assembly
stuff is built in Milwaukee anymore. Hey, that's nice, Aiden. I like that quite a lot.
Let's see that. Let's see that. Oh, wow.
That is beautiful. What are we looking at, Aiden? Can you talk a little bit about what you're holding up there? You're muted, by the way.
Can you hear me now? Test one, test two. Yeah. So this was research from about 2016. I was down in Albuquerque. Part of it, like, I mean, this is just an engineering doodle that I was making, learning, because I helped to open the Fuse makerspace in the Albuquerque Innovation District is what they're calling it now. So yeah, I've got about a decade of experience now on this subject because of living in New Mexico. And if you get around Albuquerque and Sandia Labs and you watch the skies, eventually you start seeing the little glowing orbs flying around.
Really?
Yeah.
That's where it all started at with Paul Benowitz. Are you, what base are you near, you said?
Albuquerque is Sandia.
Yeah, Sandia Labs is there.
Yeah, Kirtland Air Force Base. Holloman's further south.
Kirtland's where a lot goes on, man. Kirtland Air Force Base is everything.
I know. It's the gateway into the heart of our Advanced Weapons Development Center. So
whatever Paul Benowitz saw there, they extremely played with his mind, the NSA and the Air Force Office of Special Investigations. They really played with that guy to the point where he went insane and killed himself. What he saw there, I don't know.
Was that the dude who he drove himself out into the middle of the desert of like Arizona and did a gun mouthwash? Or
no?
There's a couple. Okay. Doty.
Kirtland Air Force Base is the center hub for the Air Force Office of Special Investigations. They've taken a lot of people there, including Stephen Greer, Linda Moulton Howe, all these people there. And a lot of these people are disinformation agents, and the government pays them more money than they'd pay a general, a lot of them, to put out bogus information. and to make everybody think everything's going on in Area 51 when everything's going on all around Area 51. There's nothing but weapons testing going on there.
Dugway is where most of the stuff has been moved out to.
Dugway Proving Ground, that's a nice spot. Yuma Proving Ground's got a lot going on too.
And of course, White Sands Health Staff, for those that are listening, HELSTAF. It's a high energy laser systems test area facility. And it basically.
Do you have any video footage of what you've seen at Kirtland by any chance? Do you have any?
Yeah, I do. It's on my iPhone.
Anything good that we can make out what it is?
Yeah, I've got there was last year on May 26th, there was if you Google Sunport power outage, it was about 2 years ago. That afternoon I was out and I flipped my phone on and was getting new tires for my Civic, and we were just down at a South Valley Mexican tire store. Yeah. My buddy Anton comes up to me and he's like, my habit once I get into Albuquerque, if I haven't been there for a while, is just I'll find a place and I'll be like,
you're sky watching.
Just start sky watching.
Absolutely, nothing wrong with that.
And he's like, well, have you seen anything? And I was like, yeah, as a matter of fact, check that shit out. And I'll share you the footage here. There's a.
Sure, you got me hooked now, bro. No turning back now.
I did load it up to YouTube, but it's just not as good. So
Getting
briefly.
back to Sandia Labs, we actually have a piece of their equipment over here. We have the Maxwell 45 kV power supply.
Wow. Yeah. Oh, that one makes me, the blue one, right?
This one actually came out of Sandia Labs, and it's 45,000 volts, 8,000 watts total, three-phase electricity to run it. I have the matching capacitors also from Maxwell, 45 kV.
Wow, are they 1 farads or are they bigger? Well, how big are they? They're huge.
Oh, these are 0.01 microfarads for the 2 of them, and they're 0.015 microfarads for the large, or 45 kV a piece.
Yeah,
they're all fast polypropylene discs.
They're super fast polypropylene capacitors.
What's the basis of that power supply? Is it a voltage multiplier circuit in there or what? I mean, to get to 45,000 volts is a lot.
Rectifier.
No, he's talking about the
yeah, he's talking about that
inside.
Transformer. That's a direct rectified output of a transformer high frequency drive system. It's a very, very lightweight supply, so it has a high frequency drive inside of it. It's designed for very rapid charging and repeat charging of high energy storage capacitors like the polypropylenes that you see above it.
Well, let me ask you something. It's not a variac. It's set at 45,000 the entire time.
You have variable voltage. It's got it's a digital encoder control. You can continuously rotate this control, so it's all digitally controlled with a switch mode power supply in order to amplify.
Oh, I love it.
It's beautiful.
I love it.
It really is. It's a fantastic piece of equipment.
We
can't say that yet because we haven't technically tested it yet.
That is true.
But if it's broken, I guarantee you I can fix it. So I'm not worried about it.
What current's coming out of there?
It's just said 8,000 joules per second, which is 8,000 watts. So we're not really sure about the current yet.
Well, all you'd have to do is multiply your voltage time. Well, your current, you need power.
Exactly.
You would need your voltage and your.
Then we'll be able to figure out if it's 8,000 watts or not. But that's what it claims to output. This is a 125.
I bet it is.
Power supply. This is a 125,000 volt power supply, and there's a voltage divider underneath it, 10,000 to 1. So. Wow. And over here we have a 16 gigacycle per second scope. We'll be able to attach to the voltage voltage divider and watch the waveforms in real time with 16.
Not for that, to pick up the electric fields of the impulse from the Marx generator, which are particularly fast.
Yeah, and also to pick up the impulses from the Marx generator. And I see Felix.
Wow, so you have a 125,000 volt power supply sitting there, plus a 45,000 volt power supply.
Let me throw this out.
I would say
regulated on the voltage and on the current, so it's a pretty.
That is awesome, my friend.
It actually broke a couple of times, but thankfully it has components that are in these little sockets that you can just swap out when they break.
Oh, nice.
Shielding 100,000 volts is very difficult. We had to make separate rows of Teflon tubing, and then a lot of Teflon in order to keep all the voltage.
Oh, I
in place.
imagine throwing a Walkman on with headphones and putting it on AM would probably be fun. The hum you would get off of that would probably blow your ears apart, you know. Yeah, you almost need a you almost need a shielded room just for the power supplies, right? I mean, you've got
we
to
need a
have
lot of shielding for this equipment. Well, we have a Faraday cage that is for most of the experiments, but the other day we were testing the 30,000 volt polypropylene for the Marx generator, and I set up a test rig and included this oscilloscope in order to read the voltage discharge time using the voltage divider as a resistor. I think it's like a 20 ohm resistor, and the scope kept on going crazy, so we had to cover it completely with basically the hot potato box. And the wire that went to it, let me show you what we did with that. It's completely covered in this shielding material. We shielded the hell out of it. And for the really high power experiments, we have a Faraday cage over here. Just don't mind the mess. We are in the middle of construction over here.
No, I'm digging this. Thank you for showing us. It's pretty cool.
So this is the
oh wow,
it's a pretty intense Faraday cage. Let me see if I can just
we got the alarm on it for when it's on.
You guys aren't playing around down there, man.
No, we're not playing around. So there's two layers.
Great.
It's a bi-layer Faraday cage. The inner layer connects to a grounded rod that goes down into the ground 8 feet, and then there's an outer layer that goes down to a separate grounding rod. The
what kind of metal are you using?
We're using aluminum, and there's these capacitors every square foot.
It's a mix between death metal, progressive,
your filter. You put filter caps within the Faraday cage is what you've done.
Inside the wall of the Faraday cage. Yeah, basically we have.
Oh, that's ingenious.
A capacitive layer Faraday cage.
That's ingenious.
Experiments, we turn this on in order to warn people not to go inside.
Yeah, man, you got to bring your
guitar
guitar
down there. I love this type of stuff.
You got to bring your guitar.
It works pretty freaking well. Right now, we have the Larmor precession Alzaphon experiment set up in there, which deals with dynamic nuclear orientation.
Yeah. Do you have a vacuum chamber at all?
Oh yeah, we have a vacuum chamber. Jeremiah's using it right now for filming the electrics.
Yeah, yes. Corey M
stuff
says
you can do with one of those.
Oh yeah, we're going to be doing that shit. Over here is the front of the control room of the lab. We have traveling wave tube amplifier, which I ended up getting for free on eBay because it arrived broken, and the guy just gave me a refund and told me not to even ship it back. But it turns out, and this is great for an electrical engineer, it didn't even turn on, which is the best thing because that usually means that it's something easy to fix. And I went into the electronics and read the instruction manual. And this was written way back in the day where they actually gave a shit about their instruction manual and included schematics and everything. I was able to go in and actually just the low voltage side, the tube was fine, but the low voltage side, that actually supplied the power to the tube was broken. So the tube probably has very low hours on it, and it's working great right now. It's only 20 watts. It's in the X band microwave generator, and that's for hitting the Larmor precession. And
microwave.
What size tube? What size tube was it? Was it a 12 or was it like something out of a guitar amplifier? Probably, I bet you.
Oh no, traveling wave tube is a very expensive tube, and
is it?
It actually costs more than the entire device. Like if you were to buy a new tube for it, it's a very expensive.
Oh wow!
How the hell do they make that shit? They must be able to. Someone makes it somewhere. Someone builds that. You know what I mean?
China. It's always in China.
You can still buy tubes right now today, any size you want.
Man, but we got to be able to build some of this shit. Like, I don't know.
A lot of people prefer tubes. A lot of technicians prefer tubes.
Let me show you the rest of the lab.
I have a friend or two in Albuquerque that are glass blowers.
Over here we have a signal generator, and this signal generator is for the X band. It only goes from 9 to 9.5. This one goes from like 5.4 to 12.5. So C into the X. This is a signal analyzer that shows us what the output is, and we have a whole bunch of probes that go into the Faraday cage to see what's going on. There's some holes in the wall back there where all the lines go in, And one thing that we're really excited about with the Alciphon dynamic nuclear orientation experiment is we're going to be powering up this klystron over here. It's inside the box, but Jeremy Riss actually brought down a power supply, 5,000 volts, half an amp, that we're going to be using to power this klystron.
Did you guys get that power supply working yet? And hey, thanks to Aubrey Dana for $10 power super chat. Aubrey, thank you.
Thank you, Dana, for the $10. So what's happening with that power supply is it has a safety interlock relay that is not working correctly. I think it's the 12-volt AC power supply that is broken. So we're going to either override it or we're going to put in another AC power supply for that AC transformer. This is our hydraulic benchtop press, and we're going to be using this to press out dielectrics or high K materials for making capacitors. We also
show me the klystron. What are you guys doing with those? You're talking about microwaves. You're talking about vacuum tubes with microwaves.
Let me pull it out, actually. So what we're doing with the microwaves is dynamic nuclear orientation, which is supposed to orient the core of the atom. And by orienting the core of the atom, you can possibly create a state where the of coherent matter, where the matter disconnects from the inertial frame, and you'll be able to move along its plane and axis just like a gyroscope can without any inertial resistance.
Are you kind of talking about getting in a superposition state by any chance or not?
I'm not really sure what a superposition state is. I call it coherent matter or nuclear magnetism, because magnetism is orientation of spin.
Okay.
Electromagnetism is orientation of electron spin. We're talking about nuclear magnetism where you're trying to orient the core of the atom. Okay. There's several ways to do it. You don't necessarily need the microwaves, but this is more of a solid state way of doing it.
Yeah, I want to see it. I want to see this bad boy.
Here is the bad boy. It is extremely heavy and has very powerful magnets on it. It's covered in mu metal, the mu metal box, to protect it from any. Yeah, this thing is pretty. Wow. This thing weighs about 100 pounds, and it's supposed to take about 8,000 volts at 1 amp, which is 8,000 watts. And we're not going to put that much energy into it. That's just maximum. The power supply that we found that Jeremy brought down for us is 5,000 at half an amp, 2,500 watts, and we'll see what it can pump out with that much energy. If we get 1,000 or 1,500 watts out of this thing, I'll be very happy. The reason why we're not using a regular microwave transformer is because, like from your microwave oven, is because those don't put out very coherent signals. And we want to be able to change the signal and pulse the signal. Those are things that you can't really do with a microwave transformer. What else? Oh, we have over here, this is for the Podklanov impulse experiment. This is a roll of copper, weighs 291 pounds, and we're going to make a coil out of that, make a very intense magnetic field. Probably use the hybrid batteries that you see the cells behind me over here to power that. And then once we have that really powerful magnetic field, there's going to be a superconductor inside of it, superconducting disk actually inside of a vacuum chamber, and we're going to impulse it with the Marx generator at 1,000,000 volts, and it's supposed to create some sort of gravity impulse. And according to Podklanov, it shot holes in the wall. So if we get any holes in the wall here, you'll know what's happening.
Guys, smash that like button, everyone watching. Everyone watching, smash that like button. You can contact us at thealienscientist@gmail.com if you have any input. You'd like to donate equipment, donate funds, anything, time, books, whatever. Contact us. Get us in touch.
If you want to come down to the lab, contact us at falconspaceprogram@gmail. We are looking for scientists and engineers who can come down and help us. And we do have housing and a budget available for anyone who wants to come down. As well. This is the box of dielectrics. It's mostly plastic. Jeremiah discovered in his years of working with high voltages that there's a special plastic in the back of a flat panel TV that can withstand 50,000 volts, and it's only like 1 millimeter, half a millimeter thick. So Jeremy brought down a broken TV, and I also found one here locally. We got some of that material for our high voltage experiments.
I gotta bring
these are-
down that other Fresnel lens so we can do some high optics experiments. What is
over
that?
here. Oh, this is a tube of Teflon. I was talking to you before about 100,000 volts, how hard it is to keep it isolated. So what I do is I have a whole bunch of these tubes that varying sizes. They fit one inside of each other. So depending on the voltage that we're trying to ramp up to, I have to put more and more of these. But we've tried this shit from hvstuff.com. Super flexible. This stuff is garbage. Don't use it. It actually broke down at only it's supposed to be good for 150. It broke down at 50,000.
What is that, like jumper cable?
I don't know. They claim it's good for 150,000 volts, but it's not. At 50,000 volts, it broke down and it broke my power supply.
Yo, so we opened that up. We got quite a few people here now in the chat. I think we got it looks like 12 people or so. No, maybe like 11. No, actually more like 9.
I hooked my camera up, Jeremy. I'm going to settings.
Aiden, I want to hear more about that thing you were holding up that you never got to. We never got to finish that and complete that thought.
Okay. So yeah, am I live? Can you hear me, guys?
Yeah.
So this is an engineering doodle. Around about 2015, I got a hold of Mark McCandlish. I'd seen that the Lockheed Martin Pulsar fly across the sky here in New Mexico. And so that it was leaving the atmosphere at that time. I'll get back to this PDQ. As it goes, it leaves these donut ring contrails. So Mark opened up and we started talking about the ARV. I got some notes on it. And then as soon as I got into the Fuse makerspace, I started doing more CAD and I did the initial design. So I don't know if you can see, there's some of the holes. So this is my first attempt at making the bottom array of the ARV. I started working on, just, brute, how do I start shaping the material, like figuring out where the copper is. And then right now I just have cardboard in. So I've got some of the preliminary CAD designs for the fastening plate from the ARV out into its radial array. Yeah, so that's, I think also in the group chat, I was talking about my last really good flying saucer discussion or experience. So it's on the Zoom meeting. So I'll let you, or maybe you can put it in the notes afterwards, but so this was March 21st, or if you check out the Sunport article. So that day, the Sunport is the commercial airport at Sandia Labs. And the tarmac is shared with Kirtland. You get out there, there's a huge, just concrete plate for all the commercial airplanes and such. And so that day we had a geomagnetic storm. It was a pretty minor one. I don't think we had Aurora Borealis. You check the Suspicious Observers web show, it's on YouTube. That's really good for learning about the global electric circuit. But so that day the airport had lost its power, and then in the afternoon, the YouTube link, that was the group of flying saucers, and it was like 2 of them holding position, and then there was a group of 6, and they were just playing it like a game of Quidditch. I wish we could put that up on the main screen. Or
Aiden, are you from the forum from years ago? I remember you.
The forum from years ago.
Weren't you from the Alien Scientist forum or one of the forums from years back? Aiden Schaefer. Boy, that name sounds really familiar.
Yeah, I'm a little bit enlightened. Sometimes I emit a familiar feeling. I've gotten it more than once, but
you weren't ever a part of any of the forums years back before Facebook
Tesla
took over?
Tech, I've been in. That's the other thing. I've been working with Tom Vallone on the Manellis device. I'm not going to go into that too in depth right now. But that's, I'm on the inner circle of it, and I've been taking some fundamental steps.
Does anybody out there have advice? I plugged my I plugged my camera in, and just like usual, with something when it's new, I can't get my camera to work. Should I probably restart everything? Do you think, or has anybody else had any camera problems out there?
PC or mic? PC or Mac? Excuse me.
PC.
You might have to, or click the like start stop video button.
Yeah, I'm gonna have to reboot, I think.
Download a driver.
Yeah, I
something.
uploaded all the newest drivers. Now wait a minute. Now it's telling me there's a newer driver.
I don't want to waste too much time on this, Stan.
All right. No. I'll figure it out. Go ahead.
Can you continue?
Flying saucers. So if you check out the YouTube link, it was it's two that were holding position. Let me get a piece of paper. Well, two that were holding position, and then the group of 6 were playing Quidditch. I didn't see it at the time, but later reviewing it, you can see that the vehicles, like you'll see them like a disc, and then sometimes like a little dot will come out. I need a little small sphere. Here we go. So maybe this is it's got to be smaller. It's more like the size of the quarter. So these crewed vehicles, some are crewed, and then they carry these small spheres, which I've seen quite a few times. And the spheres, that's why I got into Jeremy, you and I were talking about the metal spinning stuff. So the idea was to keep scaling up with what I could find, make another like field emitting array, getting a hold of like some barium titanate or the I don't know what's cheap right now, but yeah, I've also was just looking at the calcium copper titanate a couple of weeks ago. I was following up on a discussion with Paul March a couple years ago, but anyway, the crewed vehicles, they carry these small spheres, and in the YouTube video, you can see that the sphere is getting passed around the vehicles. And that's probably my best footage from around Albuquerque. I've got one other one. I haven't uploaded that to YouTube, but that was a weird, I mean, if you want to hear this one, it's probably about a 5-minute story, but it was 2 vehicles. I was in Walmart with my friends, and then I got like really disoriented. Like I kept having this like bilocation feeling, but I kept having this like urge that I got to go out and get fuel for the car for some reason. We get outside, and my neck cranks up, and then I see 2 glowing dots. They get real close to each other. Their propulsion fields, like if they get too close, you can see the vehicles will do this. They'll rotate off each other. And so that's what was happening in this one. They got close, they bounced off, and then they released one of their small spheres and held like a triangle position above the labs for a bit. And I'm sitting there just thinking about, what the hell are they doing? Like, so they're able to manipulate gravity. So I figured they formed like a temporary array between the 3 vehicles, or a mesh network. That's more of the AI stuff. I can.
Aiden.
All right, hold on.
Come on, man.
So can you
And Jeremy, let me bump in here about you. If you have a chemist on team with Ron Kita's benzene-based, very dipolar molecule, there's chlorine, there's a chlorinated benzene and fluorinated materials that are dangerous to make. Well, if you have a chemist on team, though, you may know how to do, or she may know how to do, whoever it is, may know how to actually, work with these materials in a safe manner without getting hurt. So, I mean, that's what chemists do. They work with dangerous materials and they do them without dying. So that's kind of what we need. We need to work with dangerous materials without hurting them, ourselves or anyone else. Yeah, yeah, we will. But we've got a setup that we can use for that pretty well. So I think what we really need to do is understand the chemistry, and maybe that's not the best job for us, but if somebody could explain it, and you got it on team, why not?
Fly him down here.
So
Can you see me, Jeremy? Can you see me? I've been making adjustments, bro, but that's better than nothing. So I'm here.
it's just a pure, I mean, this is just an engineer. Okay. Let me go back here. So let's see. Can you see my cursor here on the screen? I have screen share going. So there's smaller ones too. Like I said, it's in the Zoom link. I'll put it in on the YouTube as well. But there was a group of 6. I'll let it play here a bit. It's 1, 2, 3, 4, 5, 6. Sometimes you can back it up and see that there was one of their small scout vehicles being released. Yeah. No, not high speed. This is, like I said, like think Harry Potter. This is a game of Quidditch above the nuclear labs.
Are they white? And what time of day is this? It looks like they're white.
3 in the afternoon.
What shape would you say they were? Were they
these
round? Were they?
They're up at altitude. From my experience, this is not the first time I've seen this, but
Above 30,000, below 30,000.
No, they're usually below commercial. Military flies like 20 to 25K.
Right.
These are somewhere, they can either be like 15. They'll either be below military or below commercial. Unless, I mean, I've got like a dozen to 2 dozen, like, oh, there's a glowing thing. And this is one of the more magnificent ones.
Show us what happens here. This is pretty cool. Flux line or flap, you call this on YouTube?
Yeah, because I talked with Mark McCandlish, and so instead of saying UFO or UAP, I just was telling flux liner. It's
well, that's what he called the ARV. All 3 of them.
Right.
Yeah, alien reproduction vehicles were also known as the flux liners. I don't know where I kind of remember how he came up with the name of that stuff. I know Schratt very well, so
cool.
I know the history of all of it.
I got a hold of Schratt for a while. Our first discussion was like a 2-hour roundabout. And
Did he tell you he has 3 warehouses filled with UFO material?
Nope. We didn't get
then you don't know him good enough yet. He will.
Well, so yeah, I got out of, I don't know, I'll review this one more. Rewind
yeah, show us, man.
But it's playing on my screen, so there's just the little dots flying around. It's like I said, it was about 8 vehicles. So the interesting thing on this day, though, was the fact that the airport was shut down, and they just took the time to hang out over the airport and play around. So here's a pretty good point. You can see there was like 1, 2. So airport avionics, the ground power system runs at a higher frequency. Avionics runs around mil spec. That's the thing. I've been around. I have never signed a national security oath, and all of the stuff I've figured out is via public knowledge. So avionics usually runs at a higher frequency, a couple hundred. You know, you're working with 60 hertz. And so some of the higher frequency ground equipment for the airplanes, because you're transmitting up to their frequency, your ground equipment is susceptible. It's not shielded properly. So as the planetary magnetic pole flip continues to accelerate, and the grand solar minimum is approaching, then stuff like these airport power outages are going to occur more. It's, you know, it's a hard.
So they shut the airport down. Okay, you're saying they.
This is Sandia, the Sunport. The military probably had permission to fly that day, but the commercial grade avionics went down due to a geomagnetic storm. So this is just, it'll become more and more common as the electromagnetic field shrinks. The South Atlantic anomaly is the thinning of our planetary magnetosphere. And then over the next, have you guys heard of the Carrington event from like 1859?
Yes.
Yeah, so that was, that's, if you look and start, there's the Suspicious Observer's daily news brief is pretty good. He's got some stuff in there that's really useful for understanding this. But the Carrington event was the start of our magnetic pole flip. Somebody just recently made that. There's a map of the North Pole, and you see like this dot, and that's the geo-specific location of the North Pole. And over the last, what was it, like last year, they had to revise their estimate of how fast the North Pole was moving towards the South Pole, because it's been speeding up. So anyway,
I'm watching your video here. What's the highlight of it? What I'm seeing here is, you know, 4 or 5 white objects flying around. How do you know these aren't birds?
Years of experience.
Because I've seen
I know.
bird.
I've got one other video that shows the similar phenomenon, but after a while of living around Albuquerque, you get to know, you're like, okay, those are way the fuck up there. Like if you listen to the audio, my friend Anton is like,
I have it. I actually hooked the video up. I'm watching it. I found the link.
Okay.
You should put the link in the chat. I mean, I just want to eliminate everything here that's possible, man. That's what I do. You're sure they weren't birds because of the height they were flying at, right?
Plus the patterns.
Let me look here.
I just want to say, I
the
have
patterns.
friends that in aviation and fly like Reno races, and out in that area, they do a lot of practice, like formation flying.
Yeah, the Ospreys, the VF-22.
There's only one problem. There's no contrails. You'd see a contrail if that was the case.
No,
There's no contrail, man. That's the first thing I look for. That's what's got me captivated here. But they could be far closer to the camera, and it could be an illusion. But he's saying he was there. They were 25,000 feet, which would mean they've got to be, what, 30 feet in diameter to even be seen?
50.
At 25,000 feet, yeah, they got to be a certain size and diameter to even be seen. Now, you do have the sun reflecting off of them, and that's why a lot of objects look white during the day, depending on how the sun is hitting them. But there's a specific pattern going on here. I'm watching it over and over again. It is interesting. However, it's so far away. Too bad you didn't have like a telephoto lens or something on
This
there.
is
so you
shot
could
on an
really zoom
iPhone
in.
7S.
I saw a red.
And you think they're round? You think they're round?
I
Right?
know they're round because in my 2010 sighting, I saw a pair come down. They were less than a kilometer away and under. Oh, this is the propulsion field. You're seeing the ionization of space-time, or the local electric field in response to the propulsion field. They're too far up. You can't see the nutations, the asymmetries that develop momentarily as they vector around. And so this is the phenomenon. These are that's not the right. These are vehicles. These are crewed vehicles. They were playing a game that day. They had 2 watchers, and there's a group of 6. It's, if you could get it on we're losing. I see the pixelation on YouTube. The source footage on my phone is, I'll see if I can do another HD upload. But in the first couple frames, there's like, these small spherical, one small sphere, and then is released from a vehicle, and they kind of swirl around it.
What's interesting is I have a picture, I'm looking for it right now, from 2014 of 3 round white UFOs that look exactly like what you're filming, but they're only about 500 feet off the ground, and it'll blow your mind when I find it. I'm having a really tough time finding it. On my old computer, I have them saved right to the hard drive.
You would need more points of reference to determine altitude.
It'll blow your mind when you see these, because it looks exactly like what you're filming, and they're white and they're round. They're almost egg-shaped, and they are beautiful. As far as UFOs go, they're beautiful, and it's exactly what you're filming, but at a much lower altitude. They're just solid pictures. It's not video footage. Now I've got to find them.
Well, the mainstream media, they haven't experienced. My buddy Ted Rowe says there's 2 types of people on this planet: those that have experienced and those that haven't. I don't know. I mean, the whole politics of
That's how the Bigfoot community is.
Yeah,
There are those that have seen and those who haven't.
Well,
no, literally, there are people that will threaten to kill you over Bigfoot that have seen it. I know it sounds crazy, but there are people, look up Steve Isdale's channel. The guy lives in British Columbia, Canada, in the wilderness, and he has had many sightings with him, and his crowd does too, and he has a massive crowd of people. The guy gets 100,000 video or 100,000 views per day on one video. Huge channel, and it's nothing but people that claim they've seen it. And I absolutely believe if it's real, it's something smarter than human beings, and I think it probably is some kind of ET. That's my opinion. I don't care what anybody thinks. There's too many people that have seen something. I want to find this picture and of the UFOs, but I'll be darned if I can find it now. This is crazy.
I know I've mentioned this before, but I like fly drones a lot, and I tend to fly them a lot at night because they're easier to see with lighting. But I swear to God, every time I'm flying, every single time I'm flying, when I'm looking up, I see like a shooting star or 2 or 3. It's pretty bizarre. It's beyond a coincidence, I'm sure.
It's so incredible what they can do with drones right now. They can take a swarm of drones and make it look like one UFO. They can literally take 50 of them, have them in the sky, and spread them out over a mile. And if they do a light sequence in the dark, they can make it look like that UFO darted from one side of the sky to the other. But literally what you're doing is you're pulsing the lights in a sequence to make it look like the things darted across the sky. I believe that the people at Area 51 play games with the people in and around Mailbox Road. That's my opinion, because I have a cousin that's always there. He's like, you'll never believe what I saw. But the camera can never catch it. Yep, and the camera can never catch it. It sure would. The camera never catches it because it's so dark that, you know, the lens just can't pick up whatever he's trying to film out there. It drives me nuts because I want to see what he's talking about. I think they're playing a game out there with drones, because what you see with drones nowadays, they program, it's incredible. What's not to say they were doing this 20 years ago, 30 years ago? Certainly drones have gone somewhere where I never thought they could.
Is that what you've seen?
What do you think?
Like,
I've seen a lot. If you type in drones, if you type in drone formations into YouTube, it's incredible what you'll come up with.
What's Felix? What are you working on, Felix?
That's what I saw. It was a UFO.
A sphere, two spheres next to each other.
There was maybe a little bit smaller, this one, but there was two bright spheres at the horizon, and I said, "Hey, what's that?" And as soon as we saw it, about a couple of maybe 5 seconds later, it went down to like behind the mountains, and it was gone. I saw it about 15 seconds, so it was a bright red.
When and where? Like where in the world?
I'm in Quebec. It was Gaspé. No, it's a place called Capcha. It's funny because it's mean Cape Cat in English, but it's where they have a large how do you call the generator with the big ventilator? How do you call it? The wind generator. And there was a lot of that in the background, and it was the sun was about to set, and I said, "Hey!" At first, I thought it was maybe a drone or an helicopter or just a light in the mountain in the background. But when I saw it move, like poof, steady move behind the mountains, and it was gone. Then it was not a lamppost or anything like that. It was really a UFO, and I could feel it was something alive. It was not just a machine or something like that.
Yeah, the like the first time I saw the two vehicles cross or check out my local hospital, you get an impression, something like, at least I did. It was like, you know, okay, those things aren't from around here.
Yeah.
Quite frequently with the vehicle sightings over Albuquerque, you know, there's a conveyance. I mean, a conveyance of wisdom, of knowledge that happens when you see these things, and that's why you get a lot of these people. They're like, "Oh no, I know that's not us." I mean, in the Hitchhiker's Guide to the Galaxy, right? They Ford prefix at the bar, and he knows the planet's about to be destroyed, and he just lets the bartender know, like, "Hey, bud." The guy's like, "Okay, that's weird." But so the two, I mean, the fact that it was close to the horizon and you saw two like that.
Yeah.
I don't know. There are many sized vehicles. Like if that was overhead, I would say you're looking at the bottom. You might see them being close to.
Yeah, I felt that maybe
I've taken pictures that looked just like that picture he drew. Like I was taking long exposures, and I must have like bumped the camera or something, but every little point of light, I mean, everything was clear. It wasn't all blurry or anything, but it turned out to be two circles right next to each other. And
but I saw it with my own eyes.
Looked really crazy. No.
Okay. Um, quite a bit. I mean, it's David Mathis tutored me for like 6 months or so. I started writing papers because it was over in Albuquerque in the engineering environment. Sorry, I'm messing with my screen. Gravitomagnetics, gravitoelectrics. Yeah, I mean, where to start? This is, I made it with CAD, right? And then I used at the time 123D Make in order to get the basic, the buck is what I'm starting to call it. I came up with this neat little feature that I have like a snap ring on the bottom. But it's like I said, it's just an engineering doodle, right? So like here's a prototype of the McCandlish array. What did we go into? Like, so that like if I was going to make another one, each one of these plates would have to be pulled out, or we're trying to make a stack similar to this, and then it would go into here. All right, so you can see I'll be able to salvage this design and take parts out of it and make, turn it into the switching circuit, excuse me. I mean, I've been chatting with Paul Murad, Tom Vallone. No, I haven't met Tom DeLong yet. Nope. Over in San Diego, he's set up TTSA, right? So,
Tom DeLong is not a science guy. He's got some of those guys around, but
he's a man with the talent and the money. So, like, I really
think
did
they
like
used him. I think they
Joe
used him.
Rogan. No,
I was under the impression he was a show.
Well,
No.
he put that. Well, he wasn't smart enough to discern between that 2008 fake TR3B video that everyone knew was fake. Even Joe made fun of him for it. Now, I don't listen. I don't knock the guy for that, but he obviously, in my opinion, was very young at this game when it comes to UFOs, because it takes a while to figure out what's a pile of crap.
Okay, well, so may I in the Podesta emails between him, Tom DeLong, and there's one other guy that was a head honcho. He's a one-star general at the AFRL, Air Force Research Laboratories. That gentleman ended up down in the Albuquerque engineering environment. I got to talk with him a little bit. Had my MacBook with all of my research, and he just played it totally cool. McCasland.
General McCaslin. Yeah, he's the one that Tom DeLong claimed in his book Secret Machines with 2 Ks.
He's
he claimed
in the
that
know.
McCaslin,
I've talked face to face with him. He's in the know.
Right, but he claimed that McCaslin told him the TR3B was real.
I've seen that. I can show. There's one picture out there.
He has pictures of him in his book. Yeah.
No, but the one I've seen it's the black. Like, when was that? It's another flying saucer story.
He's definitely got him in his book. Yeah.
TR3B is real.
Did McCaslin really tell him that? Did you go into that detail with that?
McCaslin is a real person. He's.
Oh yeah, absolutely, he's real.
Yes, we were at. If you look, you can find me on LinkedIn. I'm fairly transparent on some things, but I worked on the ORS-4 Cube satellite. It was operational responsive space. And it was at the AAIA meeting. And McCaslin came out he was, representing his company in the Albuquerque engineering environment. And they talked about things. I got to, grill the people from Sandia that were talking about why the rocket failed that the CubeSat that was on. But then I had my MacBook and got to go into my stuff, and he just said, "Oh, what else do you have in there? What else? Oh, that's cool. Where'd you learn that?" And he did the like poker face play on it. I didn't know at the time that was the dude in the Podesta emails, but he spent, like I said, a half an hour, and I have my MacBook is full of stuff. So I guess Mac Grapher is very useful if you have a Macintosh OS. You can do some really neat mathematics with it. TR3B, I've seen it once. The pilots did a bomb of Central. Central in Albuquerque is Route 66, but the vehicle was wider than the street, which is a 4-lane street with a divider in the middle. It was totally silent, like
Daylight or nighttime sighting?
Excuse me, at night. I was at a bar. I was drinking an O'Doul's non-alcoholic beer, and the little voice was like, "Look up," and I was like, I looked up, and then this triangle just goes. It totally silent. I had the 2 red lights blinking on the sides, and then the 4 hydrodynamic thrusters or plasma thrusters coming out the back. It was so there in UNM. There's this thing called Johnson Field, has these light towers with red lights on the top because the hospital's right next to it. It was just barely above, like it'd be below what the police helicopters usually fly, and maybe 50 to 200, I don't know, 50 to 150 feet above the lights above the field.
Aiden, did you ever talk to Edgar Fouché at all about the TR3B?
Nope.
Well, let me ask you this, Jeremy. Can you pull up the picture of the TR3B that Ed did and show it to Aiden and compare it and see if they're like, was this TR3B you saw, was it an equilateral triangle? Each side was the same length. I want to know like the thickness, how big you thought it was. Was it? Love to know this
every
info,
myth, there's a single seed of truth.
I mean, dude, I'm obsessed with the TR3B. I knew Ed very well. Ed disclosed the TR3B in the 90s to the world at the IUFOC.
We're in its 2nd generation by now. Here's this picture. Turn on my screen sharing in a moment. Come on.
Oh, please do, man. I want to see this.
What I saw. Come here. Start share screen. So this is it. The triangle.
Oh wow!
I saw exactly that. The red light. The 2 red lights are blinking, and then here's the 4 MHD thrusters. I've talked with Sandia. I'm a founding arts. So I live up in northern New Mexico, and I'm what's left of a founding arts family, my little arts community town here. As a result, I'm polite and educated. So I was hobnobbing with some of our politicians, and at the politicians' party, I don't know what, anyway.
Jeremy, that's what he says he saw there. Explain to him about the thrusters in the back there.
Okay. What I've figured out, been told, so this vehicle is very real. There's that footage of over, I think it was Syria, where the 2 come down and then they go, and then they fly off. It glow. If you see it at night, you have 3 red lights on each corner. And then the thrusters, so this is human. This is the NRO, National Reconnaissance Office vehicle. Once again, I've never signed a national security oath. I'm just a straight civilian, figuring out what I've seen flying in the sky. There's a plasma engine in it, supposedly. My buddies in the space elevator community talked about that. The airframe is based off of the Hopeless Diamond, which it's had a derivative of the F-117 Nighthawk. But if you go back and like get Ben Rich's book and start, there's some of his original designs. There, you know, it's on the open internet. But this thing is aerodynamically unstable on all three axes. So it's not using aerodynamics to fly. When I saw it, it was absolutely silent. Like it made no sound, did not disturb the wind. It was, you know, I don't know. It was moving fast. Like I like to say the pilots bombed Central that day. Then I'll get into my Cholo accent and be like, you know, otra vez, let's go, USAs. We got to go bomb Central in our awesome spy plane. But anyway.
You think it was about that size there? Or do you think it was bigger than that? Or?
This, like I said, behind every myth, there is a single seed of truth. And that's that vehicle, this rear profile, you know, that's what I saw.
Huh. That reminds me more of the plane that was seen over Kansas City, where that guy filmed it in the daylight. Remember that one? The guy filmed in the daylight. There was a perfect triangle, right, just like that.
Oh,
and
yeah.
It had two big contrails coming out of the back of it. Remember that one?
This doesn't leave contrails, though.
Interesting.
Mr. Paul Murad told me that it's basically like there's 3 gravity lifters in the corners. You have a toroidal plasma generator, like a toroidal plasma motor in the middle. From there, I'm just quoting.
Magnetic field disruptor.
Yeah, and then it's, you know, it's packed full of, the the one interesting thing, if you look on like Vice, there's a Vice, like on YouTube, look up Vice, there's a Russian Jesus cult. And in the middle of it, they talk about the reporters asking the guys, well, what about UFOs? And he's like, well, as a matter of fact, we've been having this black triangle show up over the compound. So, you know, you can say that it's, you know, loaded full of stuff. I'm just speculating, but that airframe I've seen flying and it makes no sound. And
out of Albuquerque, you've seen it.
Yeah.
Do you think it lands at Kirtland? I mean, I'm really, Kirtland's been a place of mystery for a long time. I really believe that Paul Benowitz filmed something there that for the NSA to come after him in the late 70s was remarkable.
Okay.
And to attack him on the scale that they did. I think there's something serious going on at Albuquerque, and there always has been.
I already said it. It's the heart of the advanced weapons engineering environment. Like you don't, it's you do like going out onto Sandia Labs so I've got a business degree from UNM. You know, as a business student, I ended up with offices down in the electrical engineering labs, two stories down. Anything interesting out on the labs is underground. You know,
I heard they have a massive underground facility there.
Beyond massive. Like you know, this is my home turf. I'm, you know, yo soy un nuevo mexicano. I was born in Albuquerque, right?
Okay.
So I've like a law school buddy was his uncle. It really was his uncle. I'm remembering a sushi drinking story, but his uncle was working on the start of the underground excavation. He said that there were tunnels. I'm recounting what his uncle said, but so imagine like a 1960s semi truck. So he was driving in tunnels that could fit 3 of those onto a platform that goes down. They could fit 3 full lengths rigs, you know, semi trucks with long beds on it, and it was going down.
Can I butt in? Is anybody familiar with the Fermi Lab in Illinois?
A little bit, linear accelerator. One of my physics teachers was a PhD guy up there, did his like postdoc, but
Yeah, I heard they shut it down a few years
Yep.
back. Yeah, but it's still under high security. I have a coworker or somebody I used to work for that did signage there, and they were still under high security even well after being shut down. So I'm not sure what that was about.
I can only hazard educated guesses. Highly refined scientific equipment, high value materials. Well, I mean, Fermilab, it's a linear accelerator, right? Or was it the first? Well, there's circular, like the CERN. I think Fermi was a circular accelerator. Stanford Linear Accelerator, right? SLAC. I don't know. I'd have to go ask. I don't know. I haven't seen Tommy in a while, but it makes sense if there's a particle accelerator. There's going to be some really tasty electronics in there. Maybe some hazardous materials. They may have made some relatively short-lived isotopes, i.e., like, you know, they'll be around for another century or two.
Yeah, but it's still massive and it's still underground. So it's, I'm sure maybe in some way it would be, you know, connected with underground, you know, things.
DUMBs, the deep underground military bases, or I mean, anything interesting is out in the deserts of Nevada or Utah, you know, Arizona. I mean, there's a huge underground complex out at Sandia Labs. Over the years, I've talked with people, like there was a plumber. He was doing, so like, you know, you have machinists and then you have nuclear machinists. You know, nuclear materials, fissile materials, when you machine them every so often, they're radioactive. They're not dimensionally stable. So if you grok that, you know, machined radioactive material after a while is not dimensionally stable. So you have to go in and tear apart your nuclear cores. I mean, most of this stuff is online on Wikipedia nowadays.
So I wanted to hear more about experiments, more about gravity theories, and like more about
Gravity
the
theories.
I want to hear more about like the process of building this and get. I don't know. This is like I want to know more about like how we're gonna get to this. You know, how we're gonna get from where we are right now to building something. You know, like where do we?
Okay, well, so there's on ISS, on space station, they've done a molten metals experiment. This is some idea that I've received or I've been thinking about since like the millennium.
Oh, so a lot of metals experiments in space are going on. I've talked a lot about that. Like that they've been doing research into quasi crystals and also alloys in zero gravity.
Right. Well, so I've been looking. So magnesium and aluminum, their Curie temperature, which is where they lose their magnetic domain properties, is higher than their molten point. So, which means that if you put a chunk of aluminum or magnesium in induction furnace, you can get it to float and it'll turn into a sphere. They were doing experiments on these MISSE, which is a Materials International Space Stations experiment. Once you get around the military or NASA, you start learning jargon, you know, the acronym speak. So these missies on station are, you know, there's a bunch of them up there. And then anyway, you can, in free fall, you can create a molten sphere. And my idea of, you know, I'm sharing because I'm locked up. So this is one of these ultrasonic levitators, right? You can buy this kit off of Amazon or whatnot. I actually, fuck it. I encourage it. If anybody can beat me to it, throw it up on YouTube.
I've
but
seen a
you'd have
bunch of videos of this on YouTube already. The ultrasonic levitators. There's a bunch of little sound things hooked in an array, right?
Right. That's
You
you
could-
can see these are all. So around molten metals, I'm pretty sure that this would melt. But you put an induction coil in here, and then you have your chunk of aluminum or magnesium, and it's floating, and then you manipulate this array so you start getting like cymatic patterns, and you start spinning that molten metal into an oblate sphere. I mean, this is an oblate sphere. They've shown that they can do that with, like, you can get standing resonance. Like, you get these there's a pattern of little drops, points that meet up in the core here, and then you can float in water. So replace that with metal, put an induction heater furnace around it, and then you turn on this, and then you start pulsing, and you can get a standing pattern, a 3-point, 4-point, 5-point, and then it's got. I would like it to be up in orbit, because then once you have that standing pattern, then you start cranking back the heat, the energy going into the induction forge. You start cranking that back. There's got to be some differential in there, partial differential between what's going on in the circuitry. And then you're going to have something like lasers or something that you're monitoring the shape. And then, you use cymatics.
Right.
And
wave patterns, like 3-dimensional wave. Wave interference.
Right. So, I mean, these vehicles, if I take Bob Lazar at face value, because I was a kid in Los Alamos in the 80s. So when he started talking about EG&G, I'm all like, oh yeah, that big old sign at the top of the hill when you're driving up to Los Alamos, EG&G. He was, so anyway, that being said, Bob Lazar said, like, the inside of the vehicles are totally smooth, right? Like, nowadays,
he's
with
not the only one that said that. There was a lot of other people that were saying that before, and there were reports of, like, the people who examined the wreckage from Roswell said there was no evidence of any kind of known propulsion system. It was just like it was like smooth on the surface, and and even the weird alloys were reported. That the memory metal was reported. That the shape retention alloys were reported by the witnesses that picked up the material. So a lot of this stuff, like Bob Lazar gets like way too much credit for a lot of stuff, but he's a copycat in a lot of ways, because a lot of that material that he talked about
he was employed and he was brought out there. I've talked with some of the people. Like, I mean, Roswell is like 5 hours away from where I live. Because I get technical at the Roswell UFO conference. The guys, Donald Raymond Schmidt, Tom Reed. The last UFO conference, Tom Reed, he bunked me, and I got to pimp around with him in his limo. Anyway, I've talked with some of the old people. I do like Don Schmidt. I just like talking with him. He's a real steady guy. But I'm like you guys. I was like, all the old people are dying that have actually handled the materials, but.
Yeah, that's why I want to get as many of them on, to come forward and talk to, learn as much from these people as we can. Yeah, it's crazy.
Well, the UFO museum in Roswell, all of that's on archive. It's already been done. You just have to call up the UFO museum and start talking with them about it. Donald's on Facebook. Make the trip out next year, if barring COVID. Although they're rolling out the.
I'm not sure if we need to. I think if we get enough of the scientists who are doing the research into this stuff, and we just focus on the science and the materials, and because we already know enough about these things right? These alloys, these shape retention metals that they built this craft out of, that you know, supposedly, you know, everything's engineered on the atomic level so that, you know, like all they have to do is heat up these two valves, and the metal bends, and it opens up like a hole in the ship, and there's a door all of a sudden, and then they cool it back down, and the memory metal goes back into shape, and it folds back together and seamlessly.
So Lazar said the sliding door was more mechanical. It was more of a self-reinforcing structure. Like you would push in the switch, and then it would just start folding in on itself.
You know, it's super interesting. I'd love to. My interest is, how do we create that? Where's the material science at, and where's the actual physics at, and the science at, of how do we make that? And I want to talk to the people that are building that stuff and working on that.
Exactly, and that's where the Falcon Space Lab comes in. One thing that's interesting about Bob Lazar, I personally think, and I've shared this with Jeremy before, that he saw a real craft but was fed a BS explanation as to how it operated. One thing that was kind of telling about his story was his own insight. When he went into the base of the craft, he said there was these two the gravity emitters, but to him, who is an engineer, who, you know, has some experience, ad hoc, whatever, he said they looked like microwave waveguides, which is kind of interesting, because that's exactly what we are working with the dynamic nuclear orientation setup, which can explain how the craft work. So maybe we should look more at his personal insights instead of how they told him it operated, because we all know element 115 is not stable. Element 116 cannot, you know, where they added a neutron to it, cannot possibly be antimatter, because antimatter starts at a fundamental, you know, subatomic level. So that
but sodium 22 emits, when it decays, emits antimatter. It's a specific isotope. You look up sodium 22. I'm not a nuclear.
Very interesting. We're going to check that out. One thing that's kind of interesting about element 115 is that it's in the nitrogen group, and the last stable element in that group is bismuth.
Right. Yes.
Element 83, and that is something that we are working with heavily here. It is the strongest diamagnetic material naturally occurring, other than pyrolytic graphite or whatever. But the strongest naturally occurring diamagnetic material. And the Linda Moulton Howe sample that they found, they had a little bit of bismuth in there. We're going to try some samples with bismuth powder and bismuth plate inside the dynamic nuclear orientation chamber, and see what happens over there. Because dynamic orientation,
it's pattern welding though. So like, if we go back to my idea for that orbital foundry, you would create the superstructure out of magnesium, and then there's a company which I've forgotten the name of. They're doing an aqueous solution. So like pattern welding, right? If you look at the example that They All Told the Truth book has a good picture of it, and then it got real popular in the last 2 years, started floating around. So it's a layer, right? They have a magnesium substructure, or like the mother, and then they have a couple bismuth layers that are super thin. So this company, because I've been researching this shit, like in 2014, this company started coming public. And they're making tubes which have better, they don't rust as much. They have this aqueous method where they'll get we're talking zinc, right? They dump the iron pipe into the aqueous solution that's doped with zinc, do an electroplating. So same thing, like you have that.
How do you get the super thin bismuth layers, and how thin are we talking?
Well, I mean, my idea is they're microns. You and I are both citing from the same sources. I don't have my book anymore, but
is there a way to electroplate bismuth?
Yes. I mean, we got to look into some sort of aqueous chemistry like they're using, or you just do, like I was trying to figure out like a large 3D gantry with like a complex arm, and then you just have, like, remember you're up in space, so you're already in a vacuum. It's not that hard to control the environment within the furnace. So once the super frame, the space frame is quite stable, then you just come around with this 3D arm, you do chemical vapor deposition or plasma. You
One
do
second.
it-
I just want to cut you off for a second. We just got out our second or is this our third attempt at making an electrode over here? This is, what is this mixture?
That mixture is
Carnauba.
calcium copper titanate
Mhm.
and it's 38 grams of carnauba wax and calcium copper titanate mixed about 50-50 mix, and then it's also about 4 grams of paraffin. And not enough paraffin. There is some cracking evident, but it's nowhere near as bad as it was with 0% paraffin. So I'm going to add another 4 grams of paraffin, remelt this, and see what she does. Because it's looking pretty good so far. I mean, it's much less cracking. It's a lot more uniform than it was.
Oh, I feel some static field here actually.
We're starting to get there.
Yeah, I can feel a static
I can
field.
see it moving the hairs on your arm.
Yeah, there is a static field.
We're getting there.
Another thing that he did this different, or we changed 2 things, which is a mistake, which is we used less voltage.
We didn't change 2 things intentionally. We had to decrease the voltage because we were snapping over. We simply decreased the voltage as much as necessary if it's arcing over, and we had developed early on cracks in the cooling process, but we wanted to see after it cooled down, even with cracks, if some field present was still sufficient. And in this case, it appears that just some field present is sufficient to produce a mild electret, which is probably not stable, but we need to add some amount of paraffin yet.
So the calcium copper titanate, it's just, you got the raw stuff, right? It was like a crumbly reddish brown powder.
Right, correct.
Yeah, I think in order to get the higher dielectric capacity, you have to get the polished crystals, which are like $500 for a little 10 millimeter by 10 millimeter section.
Yeah, if we wanted it as a stock material, but we also had the option of following the manufacturer's procedure in terms of getting those materials to bond together with the right binder agents. We're not even attempting to try to get those high dielectric values out of it right now. We're just using the material as a raw. I mean, it's in carnauba wax, so realistically, there's no serious advantages to trying to achieve high dielectric constants in our total sample. We're just looking for a material that atomically is highly polarizable, and anything with a high K is going to offer that sort of advantage. It's not an end all be all though. It's an experiment just to see where we can get with it.
Right. And so like, I mean, in the flying saucer model, right? Like Mark was talking about the Herkimer quartz. So I was trying to see, same idea, like, can I get that dielectric material and jack it in between the plates?
Why did Mark say it had to be that specific quartz? I remember him talking about that in the show the other week, but
it's
optically clear. Sean, one of our resident researchers, amazing researcher, had looked up Herkimer quartz based on the stuff that he had heard Mark Candlish talk about, and found that Herkimer quartz contains some small quantity of carbon inclusions in various form. And so apparently the carbon inclusions have something to do with the unique properties of Herkimer quartz, and also explain why it can catalyze its own crystals in the area where it was formed, where we're used to seeing quartz only form crystals around something else that's present for it to attach to. But it can form crystals basically within its own structure because of the carbon inclusions. So that would be the difference between Herkimer quartz and just say ordinary quartz.
Okay, quick question. Has anybody looked around to see where they're extracting Herkimer quartz from?
Herkimer in New York. It's named after where it comes out.
Literally, there's a town called that? Okay.
Yeah.
Be interesting to see how much of it they're getting, or whoever's getting of it.
You can go down there and basically mine it for a price to get into the mine. You can go there and get it yourself. So if you just,
it sounds very rare, am I right? It's not something you just.
Mark was just saying it's optically clear. So if you look at like the Herkimer quartz crystals, are usually very clear.
These are lab-grown crystals.
That's why they're called diamonds. I have some actually.
Okay, but so
it's not quasi crystals.
No, they're not carbonados either. Carbonados.
What about quasi crystals, Jeremy?
Guys, I see Felix over here has something to show us. What do you have, Felix?
It's a lab-grown crystal. You can buy that. It's about $10 a piece. We don't see, but they are perfectly clear, and they're grown in a big vacuum chamber with a lot of pressure and vapor, and the thin sheet of crystal, it grows on top of it forms a crystal that's perfectly optically clear. and it's cost effective and probably.
What's wrapped around it? Is that an insulator or what? What is that?
It's just an experiment of mine.
Okay.
Make I saw a guy do that and to save fuel on his car, and I just decided.
Oh, okay.
And you plug it in. It's
plug it in once.
Sorry.
Can you plug it in?
Yeah, you plug it in basically to ground the field to the car, but I think it does something, but it's not phenomenal, but maybe a couple of percent of saving or power. You get a little bit of power, but it's not
okay.
But actually, I think it does a little bit of something. But it was just to show these kind of crystal probably you can get in various shapes. I saw them on Alibaba. There's the supplier there. You can get them, and probably you can get maybe a quarter-inch thick sheet and then stack copper sheet or some other conductor like bismuth and other laminated metals like you thought, and try a crystalline capacitor with that. Probably you can ask the manufacturer that does these crystals to because they manufacture it with crystal found in the ground that it melts and then the vapors form this crystal, and probably you can ask custom runs if you have a big enough quantity to make like you said with the carbon inclusion. Probably you could get a custom one that would fit your criteria. You don't have to mine them, and with these you get a perfect. The crystalline structure is perfect, with contrary to what you can find in the ground. So you get a perfect z-axis. It's like optically clear. You don't see that. It's too bad we can see it, but yeah, you can.
Well, what kind of crystal are we talking about? What's the material?
This is a lab-grown crystal. You can check it online.
Quartz, silicon dioxide, and
quartz, yes.
Yeah, so silica dioxide.
Yes. And what I said, I assume you can get probably a custom run with the carbon inclusion that you want. I just bought it off the shelf, but if you have large enough quantity, probably you can get pretty much any inclusion you want in it. If that's the property you're looking for whatever reason, with your crew. By the way, why do you think you need the carbon inclusion?
Why do we need the carbon?
Well, we don't necessarily think we need the carbon inclusion, but if you listen to Mark McCandlish, the use of Herkimer quartz was apparently so important to GE, who was a manufacturer of that material, that when one of those crap was decommissioned, according to his sources, they would actually melt down all of that original material and try to save it for whatever reason, because I guess it was very difficult to manufacture the whole thing.
1950s, right? So like Roswell happened in 1947.
It may not have been pure Herkimer quartz either. That's the other possibility, is because it's been reported that it had a greenish color, very much like soda bottle glass.
Yeah.
And maybe had a slightly opaque appearance, which would definitely give us the idea that maybe it included other types of materials that were separate from just the Herkimer quartz.
Jeremiah, they were using it in the capacitor, right?
Right. These were the dielectric plates between the capacitor plates.
Right.
Mark McCandlish, the capacitor plates were themselves multi-layered laminated materials formed under high temperature.
I thought it had to do with heat dissipation, is what I thought it was used for.
He's got a very different idea.
No, it's
I don't understand how Mark McCandlish got all this information just by looking at a drawing. I mean, I'm not saying he's lying, but he got all this. I know Brad's last name, where he got all the information from. This was all obtained from drawings. No one explained any of this technically.
No, Dan. I've talked to Mark on numerous occasions about this, and I asked that same question. I thought Mark was just done a drawing based on a personal report that he took over a table in some restaurant, right? No, Mark, after that happened and he started to do talks,
people started to come up to him and tell him information, and he has since then started his own little division where he has multiple researchers and engineers that are working with him in order to study these topics and answer these questions. And he's got a little team assembled that's trying to actually do some experiments. Now he's trying to
Yeah, I know about that.
Yeah, I mean that's basically what he's at. So I would imagine that any information he has is probably, and it may or may not be accurate.
It maybe just be disinformation,
Right?
And
but
the
people
what
are
about the
basically
what about
Yeah,
to
he's
the
learning.
bridge
He's
and-
learning this from people who
Right.
are walking up to him and feeding bits of information. But the nature of anti-gravity and this type of research is that there's more disinformation than there is true information. And what I believe may be happening here is they're trying to make another kind of unobtainium or hard to obtain material, such as Herkimer quartz, when really all you need is just regular silicon dioxide, regular quartz material works just fine. So that's what the concerns I had.
Well,
What's cool about Herkimer quartz is,
I've been around a long time. I understand the game works, and it is a game. Believe me, I was part of it for a long time. Whether I knew it or not didn't matter. It's a game, huge game being played. The only red flag I will say that day was towards the end was when he said that he has a friend that was a truck driver that has seen the Tic Tacs flying in around the Beale Air Force Base, and he could see them from the bridge. He could see the pilot inside of it. We never heard Fravor say anything about seeing a pilot inside the Tic Tac. He never said that. However, that's interesting. If Mark McCandlish is being fed true information, then we've got a pilot inside of it. He can see the guy's controls and everything. Actually, parked down in Beale Air Force Base. Now, I tried to find that location and couldn't find it. Believe me, I went all over Beale Air Force Base for about 6 hours on Google Earth. That's kind of what I do when I'm bored. It's a very interesting story. Believe me, it's very interesting. But yes, the whole story where he came up with the drawings from, there was 3 of those. One was what? One was 60 feet. One was 100.
Small, medium, and large.
One was what?
Over 100.
Yeah, there were 3 different sizes. Yeah, and originally they were all free hovering off the ground. Now, I swear that he said in that when he talked the other day, and your memory can get askewed, he said that there was a TV set up, and they had the TV had one hovering off the ground on the video. It was just a little different than what I've heard him say before. I don't know. I don't know what to believe about the ARV. I really don't.
He's getting information from other sources, so like you can't take everything that he says with that much validity.
That's true. I know that.
He's just regurgitating information that he heard from others. That's literally what he is. But you would expect somebody like that in that kind of position to be fed a lot of disinformation. One thing that's interesting about Herkimer quartz that I was trying to bring up before is that Herkimer quartz is actually created in a environment where the silicon carbide has nothing to attach to. It's actually a very reactive material. It usually attaches to other to other materials while it's forming, in the mantle of the Earth. What's special about Herkimer quartz is that it doesn't have anything to attach to, so it forms the quartz form their full crystal without any interference from the surrounding materials. It is found in other places around the world in its natural form, and if you Google Herkimer quartz or you search for it on eBay, you'll find a lot of that stuff coming out of China, where because there are other places where it grows in that form. Jeremiah found out that there's little carbon inclusions.
I didn't. Sean did. Sean
behind
that discovery.
Yeah, Sean found that there's carbon inclusions. I haven't found that exact article yet, but it is interesting what would happen if we added carbon to it. I'm just interested in seeing what happens with regular silicon carbide when we create a parallel plate capacitor with it. When we actually have a glass factory school that's around a half an hour from here, and we're planning on going down there and making these parallel plate capacitors, and then we're going to impulse them with the Marx generator and also the 45 kV supply set up using a Thyrotron from the Berkeley Labs linear accelerator, and that should create some various degrees of impulses on these plates, and we'll see if we can create any sort of thrust out of it or beam generation. but it's a very interesting experiment either way.
Yeah, the Herkimer could have just been a red herring to throw in there just to mess you up.
Yeah, I've
You
seen a
know,
lot of
that happens all the time. Just like the TR3B, there's so much. I hear stuff about that craft over and over. Just different information that people have made up and thrown in there that's not close to the real original story. I believe there is a TR3B that hovers and does all the nice, neat little things that Ed Fouché said back in the 90s. I absolutely believe that because the people I met through Ed, and that craft could literally turn and fly any direction it wants to from any side. It never had a direction away. It had to face like a jet before. But remember, they have TR3A Black Manas also. That's a totally different craft, but it's triangular shaped.
No, that one's I had a whole bunch of good karma show up on last November, but who's the guy? Bruce at the Kofi conference talked about it. So the Black Manta does exist. It was operational in like the 90s.
That was more of like a fighter craft, yeah.
Yeah, it's
that's
like a
much smaller too.
Turbine powered electrostatic generators.
Yeah, it's very small. It's about the size of an F-22 Raptor, from what I was told.
No. Look at the senior peg. It was.
Yep, I know it's senior.
It's based off of that airframe, but then they
senior peg. You just said, not senior trend.
No, senior peg. It was
okay. Let me take a look here real quick.
Lockheed's B1 B2 attempt.
Senior peg.
Senior peg, yes.
PEG, right?
Yep.
Surprised I've never heard of that before. Oh yeah, I've seen that before. Yeah,
okay,
that's
so
the one with the wing or the vertical the back. It's unusual looking. That's
right.
totally stealth.
That airframe's been modified.
That's a drone, right?
Not that much.
Or are they actually flying that? Yeah, they modified that thing into what would be a it's a light stealth bomber, if I remember correctly.
Right.
Yeah. Oh yeah. Here we go. Lockheed Senior Peg. Yeah.
So that my educated guess that airframe evolved into the Black Manta TR whatever. Not the 3B, not the Trent.
Yeah.
The one that it uses a.
Well, remember the mystery of the F? Do you remember the mystery of the F-19 for how long that went on? Everybody was going nuts about the F-19. John Lear wouldn't stop talking about it, and supposedly the F-19 they were all shipped to Israel. Did you ever hear about that?
No.
And I forget how many of them were made, and they're still secret. I mean, by now someone would have seen one, or the government would have came out and said, "Yeah, we bought 50 of these in secret." But yeah, the F-19. If you ever look up the mystery of the F-19, it's very interesting. John Andrews did a model.
Was it the?
I can't see your screen, brother. Hang on a minute here.
This is the drawing of the ARV that I found online from Mark McCandlish. And one thing that I thought was kind of interesting is that there's an aluminum flywheel in the center. Well, it's a flywheel, it's obviously spinning. And one thing that I learned from David Altafon, the son of Frederick, that one way to create dynamic nuclear orientation without the use of microwaves is to spin the aluminum sample inside of a laminar magnetic field. And that's exactly what you have over here. The center.
And use those tanks to do so?
No. What's going on over
Remember
here?
you had said that? You said you thought maybe that?
Let me explain.
Thought maybe that they were using the tanks for other purposes. Good.
Okay, so basically you have a spinning disc in the center of an electromagnet, and in the center of electromagnet, right there, dead center, the fields should be pretty strong and laminar, and that creates dynamic nuclear orientation, which reduces the overall weight of the craft because the dynamic nuclear orientation effect, according to David, is contagious. It's sort of like a magnet orients the electron spins of objects around it. The field sort of like propagates outward. So this disc also orients the spins of the craft around it. And then in the base of the craft, you have these parallel plate capacitors, which sort of create a thrust in order to move the craft, because dynamic nuclear rotation is not going to be 100%. So there's still going to be some weight left over that you would have to move. What I think the tanks are is oxygen and hydrogen tanks for a hydrogen fuel cell. And they're literally fuel tanks, and they provide the power for the craft. And then you have a byproduct of water, which is something that I would use in any craft that I would want to go into space with, because if you have any breakdown, at least you have a byproduct of water, and water is a great thing to have.
The bigger the bigger tanks have got to be just for the crew compartment, because it's in sealed capsule if it's going to go up into space, so the tanks and the
they would develop hypoxia very quickly in that little bad boy. Remember, there's a sealed ball within the craft, which I always found really interesting. That's one thing I found interesting, that's sealed off from the rest of the craft. A lot of people don't understand that sphere is itself.
This is the crew compartment. Probably what they have in here is the oxygen tanks, and out here is the hydrogen tank. That's how I would have built it. You would put the hydrogen tanks outside, oxygen tanks inside, so that the crew is relatively safe. And then you combine the two somewhere in here with a hydrogen fuel cell to create the electricity to run the craft.
Now, according to Mark McCandlish, what he said he discovered after these drawings were made, long time after, is that somebody came back to him and explained to him that these tanks out here, these are gaseous tanks, but what looks like tanks inside here are actually not tanks. They're misrepresented. They're supposed to be electromagnetic solenoids in order to drive this flywheel and get rotation out of it. So according to Mark McCandlish, later on down the line, he had been told that these, which he'd drawn as tanks, were actually solenoid electromagnets fired in sequence, very much like a solid-state three-phase motor, in order to rotate the aluminum.
I think this information process is very much going on. Do you think if he got the information right the first time, do you think there's a disinfo agent afterward that will come and then say, oh no, this is
well, it's a very I mean, the question I guess I would ask myself, in order to answer your question, I would ask myself, okay, let's assume that these are oxygen tanks for our own speculative purposes as the public. If we found out that instead, as the public, these weren't oxygen tanks, but we speculated that they were actually an electromagnetic accelerator for the disk, which would operate by like any other motor, the question is, would we be more dissuaded by thinking that there was a way to, or a mechanism to spin the disk, than if we thought there were simply oxygen tanks inside? I don't really see how the disinformation could dissuade us in the technological sense if we thought that they were accelerators instead of
the plasma motor. You guys, Mark didn't go over that, but the column in the middle of it.
Yes, that's the key.
Yeah, so that's where
the vortice is.
That's your moment of inertia, and then Mark and I got into some weird shit, like I was mentioning the other day. But I have part of it. I have like a series of these aluminum tubes, right? They're bigger. There's another one that's bigger and a smaller one, and a couple large chunks for making the caps. And then I had an impeller on that. And this is at I had this all set up at a maker fair in 2016. I had a couple Sandians come by and they looked at that and they're like, "Are you trying to make a plasma motor?" And I was like, "Yeah, actually I am." And they're like, "Keep working on that." Like, I mean, I had other stuff like, I had my video game demonstration up, and then because I had a laser cutter, I had a wooden models of this that I was selling. But they were able to look at the base components that I had, and they said, "You're trying to make a plasma motor based off of that Mark McCandlish's thing." So that, to me, it was like independent confirmation that what he was talking about does exist, or they've also watched it and they're like, they were at least up to speed enough to recognize the subcomponents that I was trying to put together in order to make that. But
that's cool.
Yeah, I don't know. I've got to go back and review that. Like if I
that's where I saw your name you and Mark talking on Facebook.
Oh, possibly, yeah. I mean, over the past couple of years
on Facebook, and I know actually Jeremy up there Jeremiah, alien scientist. He fell asleep. See him up there. Me and him went and met Mike Schratt a few years back and hung out for 4 or 5 days in down in West Virginia doing UFO research. And you know, I'm sure you know that Mark and
Mike
and Michael were very tight at one time. There was a little bit of a falling out, and I understand Mark's side of it. Michael meant no harm to Mark, but he kind of took over his show, you know, with the craft, you know, with the ARV.
Hey Dan, real quick, is this the F-19 that you were thinking about?
Yeah, that's the one that John Andrews, I believe, did. Yes. Yep, that's cool, Mom.
Yeah, I've had that since like 1980.
I love it. Hold that up and show everybody. You know, that was seen. Did you hear the story of the pilot that was in the air and he's looking over to the right? And there's this F-19 flying like above the clouds, like right next to him. Yeah. And he's calling TC air traffic control. And he's like, hey, is there anything up in the air here? It's Ellis. No, there's not. And he's like, yeah, there is. He goes, he's like, I can see the pilot's head, you know? And the guy's like, you need to fly in right now and land. And they had him land at Nellis and they debriefed him, telling him that he never, and he had to make the drawing. Really cool. Did you ever see it?
Hey guys, I'm gonna end the live stream shortly here. We're at 3 hours and I'm falling asleep, guys. I can barely keep my eyes open.
Yeah.
I worked today and I've been up all day. So there, just hit at 1 a.m. I'm going to stop this live stream. Thanks for tuning in. We'll get some updates going for you here on the next one. Don't forget to smash that like button. And thanks for everyone for putting this together. And thanks for everyone in the live chat for being part of this. We'll have some more updates for you shortly. But again, thanks for everyone for being part of this. We're going to continue this in